without slides. But where are my slides? I don't see slides.
There aren't any slides.
Are they not showing, or is it not?
I don't know what should I do to find my slides.
That's what I'm supposed to help. They're probably the least qualified.
Test,
to do
test.
it, so there's supposed to be a plus button on the matrix, and then load your presentation. Like, do you have it on a USB stick?
It's already uploaded.
Oh,
in
do
the
you want to
system.
pick which one it is?
I see this one. Okay, so I think it should. Okay. So I think finally we can start. It's good. Hello, everyone. My name is Slava Dubeyka. I'm not going to talk about large language model today because it's an interesting topic, but I think we have much more interesting stuff to discuss. I would like to discuss how to run machine learning models in kernel. Of course, I can share my experience of using large language models, but I think it's not so interesting. And finally, okay, you can say me, why do we need to run machine learning models at all in kernel? First of all, I think that we already see a lot of machine learning applications. And I'm not talking about artificial intelligence, because I would like to talk about machine learning. And I would like to something like make statement of the problem, share some vision of potential solution, and then we can have discussion. So first of all, we see a lot of machine learning application. And finally, some guys have been trying to run machine learning models in kernel already. So it's some from academia, from industry, because I know about some efforts to predict failures in drives, some efforts to optimize Linux kernel, how it can run, and so on. And from another point of view, it makes sense, for example, consider that we cannot write one or several perfect algorithms and then use it forever, because environment changing, workload changing, and finally, it will be good to have something in kernel that maybe can evolve with workloads. Maybe it's not easy reachable, but finally, I think it's a fair point that, for example, we cannot have some ideal algorithm or task scheduler, and it makes sense to consider machine learning for this. So I think it sounds reasonably well. And it's possible to assume that, for example, machine learning can help with improving our development process, improving testing, bug fix isolation, maybe bug fix itself. Also, it can help optimize Linux kernel performance, but we need to pay some price, because it's not straightforward to how can we run machine learning models, because nowadays what guys trying to do, it looks like pretty crazy, because we haven't floating point units operations in Linux kernel. So it's something like usually machine learning models require this stuff. And also if you try to run something like training phase, it's pretty expensive. We cannot afford this. Even if it would like to run inference phase, I'm not sure that it will be so easy, and it could be maybe performance expensive, so we can like have performance penalties. So it's not so easy point. And if you would like to answer on this question, how can we run machine learning models, we need to answer not only on this question. We need to answer multiple questions. How can we run, which infrastructure we need to run machine learning models in Linux kernel, how it can help. So it's possible to ask multiple questions, but I would like to be focused maybe on two ones. how can we run machine learning models and which infrastructure we need to have in Linux kernel to run machine learning models. And I think this is the main point for discussion. And I will share some vision how we can do this. And I try to apply this approach on two practical use cases. And maybe it will make sense, maybe not. So we can discuss this. So, and it's possible to see multiple directions for machine learning in Linux kernel. But I would like to discuss only something like machine learning infrastructure in Linux kernel. And I would like to try to consider, for example, how we can use this infrastructure, for example, for improving testing environment for Linux kernel. And maybe one of the example, for example, we can use this maybe for executing, analyzing memory access patterns. So I simply decided to select these two examples, try to show that maybe this infrastructure can work. So let's see. So, okay, so we cannot run maybe machine learning models in kernel because of, for example, we haven't floating point units there. We also expecting that it could something like have performance penalties. But why should we run these models inside of the kernel? Because, okay, so what is running machine learning models? Mostly it's Python script. And let's run this Python script or something like this in user space. Because, for example, we know about user space drivers. And, for example, it's possible to imagine that our machine learning model will work on a user space side, and any kernel subsystem can interact with user space side, with machine learning models, and something like have something from this. Because, for example, we can train in user space, we can run inference model in user space, and we need simply to have some mechanism of interaction between something like kernel space subsystem and user space. And it looks familiar because we have Fuse, for example, and potentially we can use CSFS for interaction between Linux kernel side and user space side. And finally, I prepared some picture that summarize this idea. So, okay, we have kernel subsystem. It could be any driver, for example, like file system driver or any other driver. And for example, we would like to interact with user space in some way. And for example, we could have something like machine learning library that can create this connection, kernel subsystem with user space side. And on user space side, we could have something like machine learning agent or any application, any thread. And we simply need to interact with. For example, one of the possible ways that kernel subsystem always can share some information through CSFS. For example, if it's not enough, we can use maybe something like Fuse approach or anything else to share more data. But let's imagine that we can simply share some internal states, something like counters, or some other information about internal state of kernel subsystem. And then user space agent can read this through CSFS or through some file. For example, we already have system log. It's a lot of information there already. It's possible to try to analyze this. So it's possible to have multiple channels of interaction between kernel space and user space. Finally, a machine learning agent on user space side can take this information, maybe store in persistent memory, then do some training, then finally we'll have something like trained model. And after this, if we have already trained model, so this model can analyze some data and something like elaborate some recommendations that can be shared with kernel space side. And finally, it can something like taken into account, and kernel space side can change in some way behavior. So, for example, Okay, so it's if we would like to share this recommendation not very frequently, for example, so it's possible to consider that, for example, we have something like multiple algorithms on kernel side, and finally this model simply do some classification and then something like advise kernel side, maybe select some particular algorithm. It's one of the possible way, because if you're considering that, for example, we need to communicate with user space side for every function call, it's unaffordable, of course. So in this case, maybe we need to run something on kernel side. So, okay, potentially we can do training on user space side, then something like prepare some logic and then like return this logic on kernel space side. So potentially it's feasible in some way, because in this case you don't need to run something on kernel side, because all machine learning stuff will be in user space as usually, and we can simply can interact with this user space side and receive some recommendation, and maybe it can share some what should be done, because potentially how kernel subsystem can finally change its interesting point. So the simplest one point that, for example, we can read some information from CSFS, but also we can write information there. It can change behavior of kernel subsystem. So from one point of view, it looks like feasible solution. It can work. So I'm not sure about performance, maybe, but it's one of the feasible one. And for example, one of the potential use case, let's imagine that we would like to improve testing, because potentially it's possible to see that, okay, we have syslog already. In syslog, we receive something like information about errors, about some warnings, about internal state of the system. And it's possible to imagine that we could run some user space threads that can something like parse this log, analyze content, detect some error conditions, and then finally, it's easy to imagine that this thread may, for example, report the issue in an automated manner, because in this case, human being doesn't need to be involved, because finally it's possible to find these error messages and prepare some report and send somewhere. Maybe the problem here is that if we imagine something like multiple systems, because we're running Linux kernel million systems, I don't know how many, it's a lot. And if every system will something like detect some issue and send this report, so finally it could be a lot of reports, and it needs to manage this in some way. But from another point of view, with million machine also some advantage, because if we have multiple machines, every machine running on workload, and every machine can encounter some problem. And we also can consider that, for example, system will try to isolate bug, try maybe to maybe find something like what environments need to be for reproduction of this bug. It's one of the potential ways that system can interact or proactively try to like find this issue and try to maybe isolate this issue and prepare something like environment. Like, for example, if I'm receiving some call trace with some issue, my first question, how can I reproduce this? And if system can prepare for me some way, maybe some script, maybe some additional information that can help me to reproduce the issue, so it will be great, because in this case, I can simply run and reproduce this. And maybe more important, because if system detected some issue, so maybe in this case, system like user space thread can inform kernel that in some way that let's try to avoid this code before we have fix. So, and I think it's possible to see that potentially suggested approach can work here because you could have user space thread, for example, that can analyze system log, then try to interact with kernel side with the goal to something like find environment, maybe try to prevent to run this code before we will have fix. Maybe system can found some solution. Maybe if, okay, we can use some large language models that can, for example, elaborate some solution for this issue. So it's one of the example. Second example, it's approach of, we can something like enhance daemon for using machine learning for something like analyzing memory access patterns. So, and again, it's much better to run machine learning model in user space because we cannot afford run this in kernel. And even now, daemon already have something like CSFS way of interaction with user space. It's possible to enhance this in some way. So the main question, for example, how we can use this machine learning here, because potentially it's possible to consider supervised and unsupervised learning. Because if you're talking about, and this is something like, would like to ask question, okay?
I have a question for the previous slide that you had.
Previous?
Yeah, the previous one, the example. I was wondering, I was recently announced that MCP was given from Anthropic to the Linux Foundation. And I was wondering if there is any MCP thing that can be integrated to actually collect all of these things and, you know, analyze the code and go for a fix for the LLM to actually fix this. Are you aware of if there is any sort
I
of
didn't
integration?
try to analyze all possible available solutions. So because my initial point that, for example, guys trying to run a Linux kernel, some machine learning stuff, and I simply would like maybe to have generalized solution for this. And this is something like one example. I think that already something exists.
But how would you? No, it's just if that generalization has actually a way to go through the MCP in some manner. I'm not aware. I know the MCP can be used to connect it to your LSP, but I'm not sure how would be able to actually collect all these things.
So I think, at least per my understanding, MCP alone doesn't solve it. It just gives us a way to give the AI agents enough information to be useful, right? And so, like what we have in production at Meta is, you know, we have the things that analyze the system logs and analyze the crash dumps, and then, you know, we can wire in MCP servers. So just you can say, Claude, go find me the last 10 crash dumps in the last hour and figure out what's common and, you know, do some analysis on them. Like, so you can do those steps. You can give AI enough information to do reasonable analysis and then spit something out. And I mean, we're certainly starting to do that. I would guess our Google friends already have a bunch there. Not yet? Okay. So yes, definitely inside big data centers, it's possible and relatively easy because we already have all these things. Doing them in the community is a little bit harder, where you would have to have an MCP server. The one I have will index lore, right? And so you can go ask it, go find me all the crash reports on lore and figure out what's common. And I have the indexing and the MCP server, but I haven't spent time on actually making a prompt to teach it to go get that information.
Okay.
From what I was thinking, we have a project called KDevOps that allows you to spin up specific environments and run specific tests under specific conditions. And KDevOps has integration with journal systemd, so you would be able to collect kernel messages. We don't have crash dump integration, but that's just a feature to add. So it would be like a framework for me, like to collect all this information similar to what you're saying. So if I can somehow develop something while I'm doing a feature, test across different profiles, collect all the crash dumps, all the crashes that, where when I'm doing A/B testing, and then see what are the potential issues directly connected to the sources. I think it would be interesting way of, a framework for that solution. Develop something, collect results, going through the MCP, and get where the issue is actually.
The last thing I would add is that the agents seem to be pretty good at writing MCP servers all by themselves. So you can just tell it to write an MCP server in Python that understands X, Y, and Z, and it just does it. So you don't have to spend a lot of time learning.
Yeah, I think like discussed here, like all the things could be done in all the agent stuff can be done in MCP server there. I'm kind of wondering why at the very beginning of the slide, you mentioned that you want to do it in the kernel space.
So my point here, okay, so we know the problem. We have some like error message, for example. So first of all, usually for fix issue, we need to know how to reproduce issue. So first step, it will be good maybe to find the way how we can reproduce. But if, for example, even we don't know, we know that we have issue in this place. For example, we have, I don't know, crash, some bug on somewhere. So, and potentially we could try not to call this function, isolate this function. If this driver will run, for example, we can prevent from calling this function. Of course, it will be not correct behavior, but it will be not crash. So in my vision that, for example, we can return from user space somehow in kernel that, for example, stop to use this function until we will have fix of this. So driver will work not correct way, but we will have not crash, but we'll have maybe another error message or something like this.
We have done these things before. I don't think it's feasible or it's necessary to do in the kernel. Like for example, like here you can do only inference stuff there. Like all the like anything you want to do, even agent, anything. There's a model there. You train the model, you get the information. That can be done in the kernel. That's not necessarily in the same node. You can do in a different server there. But once you get this model, you use it as the inference. Basically, that model is just the algorithm, math equation there. You can programming write in any kind of code, C code. It's definitely feasible. What we have done before is like, also, you can use, I don't like the agent idea here. Like, normally agent means you are using the large language model there, like LLM. But it's also not feasible for the kernel situation. Like we don't have that much of labels, samples there. You need to use very small samples there to get a very good accuracy kind of results there. Actually, in this kind of scenario, a traditional machine learning would be much better. Like FVM we used before, and you can just embed that writing in C code, and we have done that. We're using FVM to do the memory prediction there, so we can decide how to use that and use that as a kind of a driver code, kernel code there. So it just depends on how to use that. Like you really want to use ML in the kernel side, it would be part of the, it should be simple, tiny code snip there. And if you want to do all the things that it's not necessary, like you can all get all the information to our database, time sequence database, what kind of a database there, and then you do that. When going to the agent acquisition, you can go back, use, you can just like write into the memory file system or just the syscontrol there to change it back. So it's totally two different ways. I still don't understand why we needed to bind them together. Yeah.
I think going back to the comments you made about helping the kernel not crash when we're hitting known bugs, I realize not everybody is, a big hyperscaler data center, but I would much rather have the kernel crash, because I know how to fix crashes, right? Like, the machine reboots, it comes back up, we do it again, it's fine. Changing the behavior on the fly is much worse for us because I don't know how to deal with that. Where the system is either working how I expect or it's turned off. That's really easy. The system is working in some third way. That's much harder for us to manage as a data center.
You can do fix cross there. This is a post process, right? Like it crossed. How should I do reboot it or doing anything like? But really should be do something if pre-process, like get some information that this action, this function might cause or this operation might cause the crash. We need to avoid that. I think that would be a purpose. That would be the use case, like how to use it.
Well, I think for our uses anyway, I would much rather crash again then I would have some other state that I hadn't planned on, right? Because actually rolling out a fix for the crash is often riskier than the crash itself, because whatever kernel it is that's crashing presumably went through a lot of validation before it started falling over. So I would much rather have the known problem that I need to investigate than some other state that I've never thought about before.
Kernel itself, it could be done totally separate.
Okay, so
Okay,
I see the point, but again, so this idea, guys, anyway, we'll try to use machine learning in kernel. So my suggestion, let's provide infrastructure for this. Because again, I think like virtual file system switch. So we have generalized infrastructure, and then we can add multiple file systems. This is the same. So if people would like to do machine learning in kernel, let's provide some way to do this. We don't believe that it's something like good way or bad way. It's another point. But for example, it will make sense to have something. I think so. Because, okay, maybe this is not good example. Maybe, but maybe it can be used in some way. So, and this is why I'm something like trying to consider another example, like memory patterns analysis, because finally, okay, so something is cooking on kernel side, and you need to something like take this information from kernel, analyze on user space side, and then maybe use this information and maybe share with kernel side. Maybe we don't need to share with kernel side, but finally, anyway, it looks like that we, anyway, need to take some information from daemon subsystem, some gather this information on user space side, analyze this information, and elaborate some maybe recommendation for kernel, or maybe not kernel, I don't know. But finally, some information can be returned. So maybe here, again, if you're talking about that we can use supervised and supervised learning, for example, so it's some trouble because supervised who will provide some labels or classes of information that we can use for classification of patterns. It means that somebody needs to provide this stuff. If it's something unsupervised, so maybe we can try to analyze repeatable patterns or something. But anyway, we can do this, I think. And it looks like that it can be used in the basis of this approach. Because again, we have something on kernel side, we have something on user space side. We can try to collect some data, analyze this data, train our model or do something, and then we can return some recommendations or something on kernel side or even to user, and user can do something. But my point is that, for example, people anyway will do some machine learning. And finally, from my point of view, it makes sense. And my suggestion is simply let's try to create infrastructure that can work for everybody, that can be used. That's all. Why not? So maybe examples are not very good, but it could be multiple. For example, okay, let's considering file system check utility for file system. So I think it will be good to have some way when we can synthesize some code. Because first of all, some file system even haven't FSTK utility because it's hard to write this tool, it's time consuming and so on. I simply return to my file system stuff. But again, if, for example, we'll have some way to synthesize this logic, it will be great. It's only one example. Or for example, something like prediction of drive failures. Again, we need to collect some data, store some data in some way, and it can be, this way can be used for any kernel subsystem. And it looks like generalized way of doing this. So this is my point. So simply let's create some infrastructure that can be used.
Actually, you can just simply like a daemon, ML, not ML, like ML algorithm, and there's a triangle there, memory. They could totally become a loop. That's actually.
I have one comment here. For the interface, you probably want a more flexible interface, like eBPF maps.
I agree. You can use another interface. I simply something like short with interface, like CSFS. Everybody knows it's CSFS, how to use this. Fuse, it's possible to something like share more data than from CSFS. But of course, we can use eBPF any other way. And some of the potential way, for example, that we can synthesize something like eBPF programs that can be injected in kernel and something like change behavior. One of the possible way.
So I do think Damon is a great example of this because it set up, to have this pipeline of, external analysis. BPF gives us a lot of ways to do it. Netlink would also give us a lot of ways to do it. Yeah, and then you don't have to worry about file systems, which makes everybody happy. Your comment about, analyzing, is the storage likely to fail or something like that? I feel like those kinds of analyses are better done off the host. I think the people most likely to do them are going to be the big data centers who have some central mechanism to do that. And we wouldn't bother running that on the host.
Yeah, but we can collect data in any place because it can be remote something.
Right, yeah, but I mean, we would tend to scrape that out of dmessage or whatever mechanisms we're already doing, and then, it would happen off host. Somewhere else entirely.
Yeah, makes sense.
So I'm just wondering what's the point of the ML library here in this picture, and whether we actually need any extra code in the kernel, because we already have means to export parameters of the kernel, we already have means to export the data. Why do we even have the code for ML somewhere in the kernel?
Okay, you can not use something else because if you have already CSFS entries, potentially it's already the way. I mean here, for example, by ML libraries that, for example, it could be two ways interaction, because, for example, you need to share some data and then you need to receive some recommendation from user space side.
Yeah, but we
Take it-
have we already have sysfs for that, have procfs, we have whatever, tons of ways to convey parameters from the user space to the kernel. We don't need something ML specific. Actually, I don't think machine learning is anyhow special in this case, because there are different ways to analyze kernel behavior, and it doesn't really matter what happens on the user space side. It could be ML agent, it could be a human person running some bash scripts, for example.
Yeah, it's possible not to use some special stuff. We already have a lot of ways of interaction with user space.
Yeah, that's what I just said earlier. Like, you really don't need a big machine stuff there. It's more like a better decision maker there. Like, for example, if you want to prefetch this memory or not, like that, then you really don't need a big large language model there to do that. A simple, like you collect some maybe page fault information, cache miss information there, and use a very simple mathematical statics kind of a method, or like the traditional machine learning method we have done at VM before. So in that way, it actually could help like make better decision there. But then like it could be done totally inside the kernel. Like you don't need to sysfs there goes to the user space side, and also it would be expensive, and there's no need to save the information because all the training part is separated. Like you need to collect. We can always collect that information from the system there, all the and then we do that. We really don't want to do it in the kernel side. And another way that is you can do some online learning, kind of using the reinforcement learning there, and just you can make this decision, and you can adjust your decision maker more smarter there. But it has to be very small. Like you don't even need to use GPU at that moment. Otherwise, it seems like if you are going to use GPU side, then that's a very, very big one. In that moment, you need to do totally a fleet side. You can't do that in one GPU or in one node there.
So it depends of amount of your data.
Yeah, if we're only talking ML in kernel side, so I think that would be a more direction. That's what we are doing.
I don't know anything about the machine learning and AI, but what I was thinking about is that I see some kind of potential value of the ML library inside the kernel, though mainly because I think that our current approach works very well and we have no problem at all because we were writing our kernel interface to be human friendly. We are writing our kernel log that easy to understand, and also we export some of the metrics in sysfs or BPF in a way that both human and machine can understand well. And now the ML of today, the LLM, is very good at understanding the human-friendly things, and I think that that's why it is working very well. But I'm also thinking that there could be some more efficient way to let the LLM or some kind of futures AI better understand what's going on in more efficient way than right now. That is, we are training a very big models, and I'm sometimes afraid about that because if I don't have a way to use such kind of models, how I will use that kind of tools, and if there could be some efficient way to communicate our internal findings with the some kind of machine learning tools in a more standardized and efficient way, I think that could also be valuable in a scale. It is small scale in individual machines, but that could be a big scale in for a fleet level. So I think if we can find some standardized way and efficient way to better communicate with the outside world from kernel, then that might be something that the ML library in kernel could give us some values. That's my feeling.
Okay, thank you.
So I've been playing with, just for my selfish needs, with SCADX and how we do scheduling better on really my laptop. I was stuff like, for example, if I'm using it interactively or am I running a build overnight, is the laptop hot? Is my battery running out? Stuff like that, and try and feed it into a model and see what happens. And I kind of agree with what you said. It's been a pain extracting the information I need from the kernel. Every subsystem kind of does its own thing. Everything is, you have to figure out how to access different bits of information. I'm not sure it needs to be solved on the kernel side or whether we need something on the user space that will help kind of aggregate information and present it in a unified fashion that will enable these users to be much easier. But it's definitely something that would be great to see, like some, thinking around it at least. Not gonna make it.
Hey, hello. I also want to share my perspective because I have implemented MCP kernel source code server, and then I also delivered a talk in Chinese kernel conference last month. Yeah, my idea is that when the crash dump happens, I try to capture the code trace, right? But to analyze the code trace, we need to have a precise kernel source code. So I created a kernel MCP server and to use cscope to find a specific function code and where is the function in which file, in which paragraph, and I try to collect all of the kernel code trace for LLM to analyze. And I define the problem is that I want to find the existing kernel page to resolve the problem. And then I also try to construct the Git log into the vector database and use RAG as an external resource for the LLM to call the tool to analyze what happens. And eventually I found that it's really precise because with my kernel code trace, because I have fixed a bug in the MM subsystem. I use my code trace as an example and try to find my page to facilitate the kernel backport. So I think that's another approach, and maybe try to make this ML library into like a user space, try to use eBPF to collect the information for the user space to do the further analysis is another approach. Just my 2 cents, yeah.
Okay, thank you. So another maybe 1 minute comment or question because we're running out of time. So if no other questions, I can finish. Thank you.
Let's maybe give everyone a couple of minutes to switch rooms and everything. Yeah, all right, let's get started. Good morning, everyone. Thanks for making it to the last day of LPC, and nice to see so many people in the room despite Saturday morning. So I'm here to talk a bit about another absolutely uncontroversial topic, which is Linux CVEs. And just to make sure everybody's on the same page, this is actually the same slide of last year. To give a little bit of context, since now 1.5 years or so, almost 2, Linux is a CNA, which means Linux is the only authority that is authorized to file CVEs for the kernel. The volume of CVEs for those who have to do vulnerability management on the Linux kernel has dramatically increased. I think these numbers are more or less still up to date. And this means that we have a challenge as individual companies, but as a community as well, to triage them all in case you cannot be rebasing your kernels or upgrading them all the time to the stable versions. And this actually translates to a number of different challenges depending on the business that each different company is in. For us, cloud providers, I speak for myself, but I work at Google. There is a huge problem with rebooting machines. It's something that basically we can't do. And we need to take decisions based on the severity of the vulnerability that can go from ignoring it completely because it's absolutely uninteresting for us to live patching the entire fleet because we need to get the bug off the fleet as soon as possible. And here there are a number of aspects that come into the game, threat models, different permissions, perhaps downstream patches as well. And the question that we asked ourselves last year was, is there any space to collaborate? And last year's session was, I think, particularly successful. The room was even more full than this year. Many folks from many companies reached out, and there was a clear intention to collaborate and try to start some kind of community-powered analysis that we could share instead of performing this work independently. We also received some support from the CNA team, and the idea was, let's try to make this happen despite the differences in threat models and deployment scenarios, also without demanding any engagement from the maintainers themselves, who are already busy enough. And that's how we started something that has this Linux CVE workgroup name. There's just one name like another. But again, the idea is, let's get together, share basic and undisputed CVE metadata with the community, trying to follow a template that is as threat model agnostic as possible, so that the information can be reused by anybody, regardless of their deployment. And the core idea really is that everyone is already doing this stuff already. Either you are rebasing and updating your kernels all the time, or you have to do this. And so since so many people are doing this, why don't we just try to do it together the same way that we developed this kernel together? And the final goal would be to become some kind of established, and I wouldn't use the word official, but established source of vulnerability assessments. And we started posting our assessments on a GitHub repository. We meet on a bi-weekly basis. We chat on IRC every now and then. I want to give you an example of how it looks like. So I've taken one of the CVEs that we have in the repository. And this is an idea of more or less of the template. Of course, this is also evolving, right? It's not written in stone, but if you look at more or less all of this information, this is pretty, it's valid regardless of whether you're installing Linux on a helicopter, on a server, on a laptop. If it is a use after free, it is a use after free everywhere. If it is, if there is an exploit that is publicly available, that is true regardless of what you do with your kernel. And the idea is that different people may stop at different points. For example, if you, again, run Linux on your helicopter, maybe you don't worry about local attackers at all. So you ignore the vulnerability at the first line. If you're a cloud provider, maybe you care, but maybe you don't care about privileges that need capabilities. That's the case for us. So this is more or less the idea. This is also a nice example because there is a public exploit in KCTF. Luckily, that's not always the case. One thing that we ended up discussing quite extensively, and I want to make sure we get covered so that the debate doesn't center around this. So we know there is CVSS, right? We know it's the industry standard, and some organizations need to give a CVSS as part of their advisories. The agreement of the group is that while being the standard, it is not so great when it comes to kernel vulnerabilities. It's quite hard to distinguish some edge cases that we see all the time. It also just tends to be specific to vendors and threat models. Once again, something we're trying to avoid. It actually happens quite frequently that the same CVE has different CVSS scores depending on who rates it, and that's something we're trying to avoid. But the idea, and of course, happy to hear if anybody disagrees, is that this template is somewhat of a subset of a CVSS score, a CVSS vector. So one could potentially start with the template and then fill what's remaining to come up with the CVSS. So what's working? It's definitely a space that has seen a lot of progress over the last year. It's nice to see so many stakeholders coming together and trying to solve the same problem. And there's active discussions on a number of different threads on areas where we can improve, and I'm going to be talking about it in a moment. In terms of raw numbers, that's a little over 700 CVEs that were analyzed, which you may argue are quite a few. You may also argue they're not that many. It's only a subset of the many CVEs that were published by the CNA. So that's one of the two main points that isn't really working so well, the throughput. The other one is the latency. We tend to, even I personally tend to work in batches, which means I take the analysis that my team has done, and every now and then I publish it upstream. That's not really the good way, the right way to do it, because it means that everybody in the meantime has done the job already, and it kind of defeats the entire purpose. So latency and throughput are the two main things that we need to work on, so that we can actually make that collaboration happen the way we thought about it. And then this CVSS point I mentioned, we seem to agree, but it's also something that, again, has come up multiple times, and I wouldn't completely rule out that one day we won't reconsider this choice. So quickly on what's next, and then I'd love to hear from the room. I think really to address the latency and throughput points, there is no other way than integrating contributing to this project as part of our internal processes. What I mean here is that, again, I can speak for what I do. We have an entirely independent pipeline where we receive bugs, analyze them, post some comments on some issue tracker, and take decisions based on the severity of the vulnerability. And then completely asynchronously, there is somebody else, me, taking these comments written by humans and converting them into the template. That's not really a smooth way, and that's where the throughput and latency problems come from. I think the way forward here, but I'm not sure how complicated it is to make it happen, is that it needs to be embedded in the tooling that we're using. And for example, I know Canonical has been moving concrete steps in this direction. For me, that's the first and sort of more the easiest step forward. But then obviously everybody is pretty excited about using AI for this problem as well. And to be fair, AI-powered analysis have become much better over time. Of course, we have tried to throw a CVE at an LLM a bunch of times over, let's say, the course of last year or last year and a half. And you can tell that now with the recent developments, the result is much more satisfactory than the crap that it was spitting out at the beginning. So that's definitely one venue to explore. I think LLMs can also be particularly helpful with perhaps some subtasks. Sorry. So for example, when I said I take whatever Google produces to post it upstream, I use an LLM, but I don't try to make it do something too hard. I just tell it, please translate whatever a human has written into a template. There was a talk recently, I can't remember which one, where somebody was pointing out that LLMs perform much better when you try to force some kind of structured output instead of letting them be too free. And I think that's true, and it's particularly applicable here. Once again, I want to also stress that, sure, AI can help and can definitely make our lives easier, but at some point there has to be a human in the loop. And yeah, so far we are not really at a place where we can leave that human out of the loop. So to me, the most interesting discussion points are whether you think any of what I just presented makes sense, whether you think it doesn't, and then ideas on how we can move forward, what the community would want, whether the community finds this any helpful. And I also see a couple of folks from the CNA themselves, so I'm also happy to hear what they think. I also know the CNA itself is using AI to aid some of the tasks. So yeah, I didn't want to talk too much, and I was hopeful to listen more than talking.
Something that was coming into my mind while you're talking about sharing triages is, so I understand as Google, we're kind of publishing triages, but we're not really like using anybody else's triages yet. I guess part of that's because of the latency. But another thing is that like, I wouldn't want to just start ingesting those triages from GitHub and acting on them without a process, like some period of, experimentation and building trust, basically. And I wonder if that's something you've thought about. I've noticed that in the Rust world, they have this thing called cargo audit, I think it's called, where different organizations can publish their reviews of a crate. And they have something a bit like, they have this metadata template where they say, like, I've reviewed this crate. It has some unsafe code in it, but it follows all of these rules that we've written in this document here. I come from Google. And then you can say as a user, I trust the reviews that come from Google, and I also trust the reviews that Google trusts from anyone else. Mm-hmm. And so there might be some inspiration there to make it easy for people to actually start consuming the shared triage information.
Mm-hmm. Yeah, no, it definitely makes sense. I think this is something also together with another point that has come up a few times is the one of conflicts, right? What if two companies are perhaps concurrently doing the same thing at the same time? I think those are interesting problems, and it's problems I'm happy to have once we have enough volume that we actually are confronted with them. I think we need to get the volume first, but yeah, I think something like the crates review approach is a good one. Yeah, something that we can explore.
So I know you don't want to dog shed this too much, but why was CVSS not fixed rather than making your own format?
Yeah, so I can try to expand on that. The idea is that Well, maybe you can maybe we can chat a bit about these edge cases, for example, right? Take a warn on that gets commented away, gets patched away because it's triggered in some circumstance, right? Normally, CVEs are issues for this because we have panic on warn deployments. A CVSS here would look like maybe high availability impact or something like that, right? So if I only look at the CVSS and I see high availability impact, as a cloud provider, I may think, oh, well, this might be a DOS. I maybe need to care about it, right? And then I end up having to read the thing and discover that it's a warning and I don't care. Ideally, we would have an easier way to classify that and compare it against an actual DOS, right? Where there is an unpointed reference, for example.
So in the previous example, just comparing it to the doc.
Mm-hmm. You mean the template?
Template, yeah. This assumption here, when this is made, is that every configuration is turned on. Like, for example, warn on panic would obviously panic the machine. This example, it's used after free, not a good example, but like for denial of service, could end up being either denial of service for warn on panic or not. So what is the assumption here in this build when you make this document?
So we tend to write it in the notes if it's a warning. And that is something that immediately stems out if you analyze a CVE. So you just write in the notes. We could have a separate field in the YAML as well. Why not? But the idea is that you can see and then judge for yourself, and without making any assumption on what flags you have on and off on your configuration.
So that's the expectation on, like, say I was to contribute to this example, you'd expect them to write that for all configuration options that affect that make that state. Not use after free, but like, for example, when it is warn on panic, this is denial of service when it's warn on panic. And say, for example, like there was a config option that then allowed this to become LPE. Sometimes there's memory overwrites that write over into nothing important that can't be prevesked, for example. So in those examples, when there's a config option, you say this is LPE when config _ buggy code is enabled. Is that the level of analysis you're expecting in these YAML or whatever format that is?
Ideally, yes, I would say. Well, let's say if something like if you see something like this, you can maybe let's try to take it the other way. We once again try not to make any assumptions on the configs or anything. So if you see an assessment, it means the people who did this thing cared about the vulnerability and maybe have that specific config enabled in their kernels, right? If they have done a good job, they tend to say it, and they say you need config XYZ to be on. Ideally, this is universal enough that somebody else comes, reads the thing, reads that it depends on some config, and then takes their own decision based on that. That is, yeah. I realize that as I say this, we are the sort of. I mean, this cannot be there depending on the quality of the assessments, but yeah, this is the idea.
I think what you said though calls out a good reason why a sort of YAML custom config format is preferred over CVSS, because I hope it's relatively lightweight. If, 6 months into doing this, you realize that, like, oh, we're constantly noting in the notes, like, oh, this will crash your machine if you set panic on warn. It should be relatively easy to then say, oh, well, let's just make that field in the YAML. And like, for example, the same with like configs. We actually have automation that compares. So when we look at the fixed diff, if it doesn't change any code that we compile, then we assume we don't need to worry about it. And we could easily probably extend that configuration, that automation, and then you could like encode the results of it into the YAML, right? So there could be a field that's like, you only care about this bug if you set this config, right? So there's agility there that you wouldn't have if you were using CVSS.
Have you considered that having to first adopt this format organization needs to adopt this format first before they can contribute to the project.
I think you're going to have to use the thing closer to your mouth. Yeah.
Organizations have to adopt this format first before they can contribute to the project. But in our case, we pay humans to look at all of those kernel CVs and produce evaluation, and we're stuck doing CVSS scores because that's what auditors require, like ultimately later in our process. But I cannot contribute those evaluations to the project because I will have to invest in first adopting this format.
Mm-hmm.
And so this.
But so I don't think I've ever, definitely not at Google. I don't think I've ever had to write a CVSS vector. But the question I have for somebody who's doing that is, don't you ask yourselves these questions before filling in the each and every field of the CVSS? And once you do that, wouldn't you be able as well with the same information and sort of the same mental effort to also fill the template?
Yes, we do answer the same questions. We do assess it's a LP and we infer a score from the LP.
Mm-hmm.
But we have to all of our tooling is built around CVSS, and that's what we produce, it's what we track.
Yeah. And
so we kind of have to adapt to this. This is why I joined a few of the meetings early on that we can contribute to this thing, but it's just too expensive.
Mm-hmm.
I cannot justify it.
Mm-hmm. Yeah, no, I understand that, and like I said in the final slide, that's one of the points that haven't maybe worked so well.
One of the big gaps that I can see just in that format is you're not talking about architecture hardware. So a CVE could not affect PowerPC, and you'd still have to look at it in this format. You'd still have to identify it, and even identifying the CVE out to a specific module or config. Being able to track down which kernel you're running, which hardware, which modules are installed, really impacts the effectiveness of a environment. And it might be a really high scored CVE, but you're not running that hardware, so you don't care at all.
Although I think that's some degree of filtering that can happen at the vendor level, right? You know exactly what config you have, what hardware you have, and maybe you can, for example, that's what we do. We filter away directly based on, like Brendan said, based on which files are touched by the fixed commit. So if we stumble upon if there is some PowerPC issue, we don't even see it at all. And we won't be, by the way, producing any assessment for it because we just don't triage it, right? And while it is true that we could also integrate this information in this thing here, I don't think you can base your decision purely on the template. It's meant to help you, make a decision, and you will still have to look at the CVE itself. So once you do that, you can have some automation that just discards it based on your config, I think.
Yeah, so somehow based on that, I was wondering whether it would make sense to put a minimal set of config options as a kind of depends on value in there in the template, where you could then go okay, if I'm evaluating on my kernel, I'm checking the depends on section there, whether I have those options enabled or building for those options, and then could say okay, I need to look deeper into that or not.
I think what they're saying is we should add more stopping points in the template to do a quick analysis. So I don't know why not having a depends on config or depends on certain module or hardware architecture.
So this template supplements the CVE. So you would look at the CVE, which lists the files that were affected. And then you could do a tally between files affected and then back to the def config option.
It's coming for me. I really think you have to define your workload. I think that it's not just files or architectures. I think if you look at this, for example, if I change the configuration slightly, a lot of these answers change. It can turn from a use after free to like a privileged denial of service just by virtue of different configuration. I really think it will be best if you define actually the stuff you care about, especially since you're not analyzing already stuff you don't care about. You might as well define a config and say, okay, we're cloud vendors. We care about x86, we care about these drivers, we run with user namespaces, that type of thing, and just go with that. You'll need to do it anyways when you do CVSS, right? Might as well just get it over with.
I mean, so that's one way in which we can evolve, but the moment we say this is the sort of profile we have in mind, we also exclude everything else, right? And this means if you look at this specific effort, for example, sure, I'm speaking on behalf of a cloud provider, but we also have Canonical, Oracle on board, Red Hat, other organizations that have other kind of deployments. And so my point here is not to say, no, we shouldn't do it. I think it could be one way in which this evolves, but we need to bear in mind that the moment we decide to restrict our scope, we also restrict the sort of the people who can contribute, basically.
But you're already kind of restricting it. You said you're not even going to review PowerPC CVs, right? So you already effectively restricted it. You're not going to do it for every CV that gets published. You only do it for a small subset.
I am not going to do it for every CVE, but for instance, my team will never be triaging some Bluetooth issue, right? But if in parallel, Red Hat cares about Bluetooth, they can post their own for Bluetooth.
Yeah, and they can do their own analysis and also post their own CVSS score. I mean, you can have multiples.
It's contribution into this, right? It's open source. So if you care about a particular issue more and it's relevant to your threat model, right? I do think Sasha has a point about like what is the impact, but in this particular bug class, Sasha, there is no mitigation for use after free, right? Memory corruption is a memory corruption. So in this situation, there's nothing that will turn this particular bug into a crash, right? It is still local privilege to that locality, right? Like you can escalate privileges within a user namespace, for example. Let's say I'm an unprivileged user within a user namespace. It's disabled. Okay, then I still could elevate privilege as an unprivileged user by grooming heap and using that use after free into like to change classic exploit pattern, right? So this particular example, I do get your point. A UB-SAN bounds being enabled properly on the kernel and an off by one error could be a crash on one system and could be a privilege escalation on the other. But this one, I think, is a special case that we haven't solved with our tooling yet.
You guys do your own CVSS score. Let Red Hat do their own CVSS score. We'll put them in the same record. Everyone will have it.
But yeah, so again, this is one way, right? But what you just said is that then everybody continues to do work independently, which is what we're trying to address. Maybe the outcome of today's discussion is that there is no space for collaboration, right? And I mean, I'm ready to accept that. But if all of the companies, if all of the companies do their own CVSS, we're basically where we are today with a bunch of different advisories, sometimes saying the same thing, sometimes saying a different thing, through some score, some magical CVSS score, based on which we decide what to do.
Say this afternoon I come home, I do a flaw analysis, and I take a look. If I commit more than that, like I make a GitHub pull request into your repo, and I've got extra fields, this is what I think. It depends on what happens. Does it break your workflow? Like, does it change anything?
No.
Oh, it's cool. Okay.
I would say so.
That solves a lot of problems right there.
I would say I'm not actually involved directly in this, but I hope that the design principle here is that you should be able to contribute exactly as much or as little as you're able to, right?
Of course.
Nobody's expected to do anything that they don't have time to do if it doesn't benefit them directly, right? It's just
thanks
what you have.
Actually, maybe that's something I should have made clear, but also nobody forces you to fill all of these fields. If I don't know, say that this is a physical bug that for some reason you need physical access to, right? And potentially you could also just say reachability physical, leave all of the rest empty. That's so one of the core ideas, and that's also what I was trying to tell earlier, is that so the vision is everybody's doing this stuff already. So let's try to share what we're already doing in a format that is reusable without asking people to do more work. Now, you just pointed out that this is more work because of the CVSS versus format. So that's a point that we can chat about. But definitely, the idea is not to ask for even more work. That would be unreasonable because I have spoken to these folks on a biweekly basis and I have seen their faces. I'm not going to ask them to do any more work. They will not give it to me.
What's the end goal? Like, is this historical information about CVs, or are you trying to get to a point where downstream users can use this to make their decisions?
Yeah, the second. We are trying to get to a stage where CVE is published, I don't know, today, and not so long later, you can see this. And when you have to do your own CVSS or your own analysis for your company, you can take this instead of opening the code, reading the commit, and trying to figure out what's happening.
Are you tracking how close you're getting to this? Like, how long does it take today to get this NVH data out after a CV is published?
Yeah, exactly. Well, I'm not tracking it because we're not. I wouldn't say we're close. I would say we're definitely closer than where we were 1 year ago, where we were nowhere. But we are. I cannot even give you a number, but I think the assessments now can come anywhere from 1 week later after the CVE has been published to 6 months. So that variance has to be fixed if we want to go somewhere.
The way that this is most likely to deliver value sooner, though, is in retroactively evaluating your triages, right? Because I'm sure you've had the concern that you don't really have a feedback mechanism, right? So we sometimes look over each other's triages, and I sometimes say, oh, I think you got that one wrong, or whatever. But like, the only way we really find out when we've been like completely systematically misunderstanding what it is to escalate privileges is when we get pwned, right? And it only happens once, and that's not a feedback loop, right? Whereas what this can offer, even if the latency is too high to actually let you use it as an input to your operations, is it lets you say like, oh, well, let's look over for the last month, like did Red Hat come to the same conclusions as us? So that's something we can probably get quite soon, right? Maybe even now, right? You could probably look through the ones that we've published and find out, do we agree? And if we don't, probably a useful discussion for us to have.
The risk of exposing, I'm not a big believer in collaboration in this space because we're kind of time constrained, right? You're doing your evaluations based on your time constraints. We're doing our evaluation based on, like, everybody is in a rush to get the decision. So nobody can sit and wait for somebody else analyzes. But you consider that you're effectively building maybe training data to like get the AI to make better automated decision on evaluating kernel CVs. Because the way I see it, like what you're building is more historical than real time, but you're enriching the CVE and like you're maybe producing data that we can use to train the AI and assessing that like those CVEs are in fact like LPs and that we care about them in this context and that other context. And maybe to me that sounds like maybe a more realistic goal than try to get all of those collaborators to produce evaluation fast enough that they are useful to somebody else who's also working on a time crunch.
Mm-hmm. I don't feel, or at least when we started this, we didn't really feel like there was the community needed some kind of data set of past CVEs. So no, that was not the intent. Maybe that turns out to be the value added by this initiative, but that was not the intent. The intent was to be able to help us do this on a daily basis. That requires, low latency and throughput. Agreed. Yeah.
So I sympathize with what you're saying. You're under a time crunch to get a resolution quickly. So at the moment, in my head, the workflow goes like this. You make the document, you submit it to GitHub, it goes as a pull request, someone approves it. is the goal to have trusted reviewers or trusted committers, for example, like from companies, that reliably, or people that reliably make these patches to reduce the time to it appearing in the list?
As of now, there's no review process.
So just straight commit.
Yeah.
Okay.
Hello. The only thing is that you mentioned on the other slide that you're thinking of tackling with LLMs and so on, and this is also a classification problem. So I think I already saw some academia stuff using BERT and transformers and so on, classifying the historical data on the GitHub repositories from NVD. So that's actually, I know everybody's running for LLMs, MCPs and so on, but that's actually, BERT can be used for that and transformers and so on.
Mm-hmm.
First of all, thank you for doing this. And I have a quick question about, so I understand that I believe that you are doing this not only in manual way, but also using some kind of tools and also developing your own tools together. Are there some such kind of tools that others can also use and share?
So before we started this group, there was a previous initiative that kind of faded away, for which we developed some stuff, but you can find it in the repo I mean, by the same user in another repo, but I wouldn't say there's anything particularly useful that we did build something to filter away CVEs based on compilation, the thing that we were discussing before, whether you're using or not some config. I mean, that's something you can probably code in half a day, so nothing too useful, I would say.
One more quick question. What is the biggest challenge at the moment at improving the latency and throughput? Say, do you need more coffee, more human, more tools, or more consistent support from employers of different parties?
What I'm trying to figure out, this is exactly the core point, right? What I'm trying to figure out is exactly, is it a point of priorities, humans, limited resources, or is it a process problem? Because if it's a process problem, we are here together to solve it, right? And that might mean we change the template in some way, or I don't know, we define a threat model better, what Sasha was mentioning. There's many ways we can evolve this, right? And none of the stuff, I want to stress it once again, none of the stuff I presented is written in stone. We can change it anytime. So my feeling is that we just need a more structured process from each and every contributor, starting from Google and myself, right? Now the question is, can we get a more structured process? Is it realistic with the current model, or do we need a better model before we can get a more structured way to contribute?
Actually, maybe I misunderstood that, but I think the initial goal was to kind of spread the load of evaluating the CVEs across multiple companies, persons, and so do we have any way to coordinate who is working on what?
We currently don't, because you can assume nobody is going to race against you and post the thing 1 minute before you did it.
Well, that could lead to the problem that everyone is kind of either waiting on someone else, or everyone it's on the same thing.
We could get there. I would love it if we get there, because it means everybody is actively contributed to this all the time. Then we will decide that we do the odd numbers and Microsoft does the even and something like that. But let's get there first. That would be my answer. Over there at the back.
Sorry for narrowing the question down a bit, but what I hear is everyone have some sort of filtering going on because of the CVE volume. And what was proposed is that maybe we could have some more annotation in the format so we kind of share the filtering load, so not everybody has to. That's my understanding. Not everybody have to have their own tool of filtering of some sort, but that couldn't really happen because our process is vastly different, or that our config is so different. Is that kind of the consensus here, or am I?
So I'm happy to be proven wrong, but I don't think filtering is what's missing right now.
Okay.
I think everybody can do their own filtering. Also, the fact that we don't post assessments for all CVEs means that you're already, you're already in a position where you have to look at them anyway. So, like Lee pointed out a few minutes ago, this is just a supplement, and I think you can figure out whether your system is affected by this CVE, not this one, but I mean, the one I was presenting earlier, based on the files affected by this bug, and then you figure it out. You figure out if you need to look at this even before asking yourself whether this exists. That would be my take. Okay, so we have 3 minutes left in case anybody has any more thoughts to share. Otherwise, you can grab me anytime over the rest of the day, and I'm happy to chat about it. Just to share once again, this is the GitHub, that's the IRC. Yeah, we welcome all contributions.
Maybe a very silly question, but why is the domain name is having cloud LTS? That sounds like if I'm not working on cloud, I shouldn't contribute.
It's a great question. Yeah, so this is the initiative I mentioned earlier. At the beginning, the idea was let's try to create something that we will call Cloud LTS, which is sort of a refined selection of stable LTSs that is only applicable for cloud providers. And I still find it a very interesting idea, but triaging CVEs is somehow a sub-problem of that. Now, the cloud LTS idea has faded away over time, because if we can't get to triage all of the CVEs, how can we get to triage all of the stable commits, right? So we haven't been making any progress there, and we instead decided to try to open up, since this is a problem that also non-cloud providers have, but we reused the same the same user on GitHub. It's probably worth changing the name. So what KP is saying is that we should change it because it might scare non-cloud people away.
If the indication this gives is that this is a cloud-only project, then names change.
Yeah, we do it all the time. It's fine.
Project more, then we will take all suggestions.
Of course. Okay, thank you very much.
The hardened node.
Who's here for hardware in the loop? Yeah. Who's not here for hardware in the loop? We can just talk around this so Jan can hear us. Yeah, that's a buff.
Person leading the thing.
Leadership optional, I guess.
Exactly. Does anybody want to stand up
to show some?
Well, no, I think it's more a matter of like what do we want to talk about? At least on camera then. This is the.
Hello. Yep. There we go. All right. Hardware in the loop buff. Let's see. Who do I have something? No, I do not have something prepared.
Can you start sharing like what you currently do and the challenges you have?
Oh yeah, sure.
Yeah. No, yeah.
Yeah. Okay. So I work for Garmin. We do hardware in the loop testing using LabGrid for I want to say like 30, 40 some odd products. It's all integrated into our code review system, so people push up code reviews, and then it goes and gets tested on actual hardware devices, and then once that passes, then it can get merged. It works really well for us. Yeah, I would say the biggest challenge that we have is usually just the general reliability of dealing with hardware. You know, relays fail to trip sometimes and things like that. That can happen only occasionally, you know. Oh, okay. So I guess this presentation was about this other hardware in the loop testing thing.
Yeah. They're not here though. So.
They are not here, so I don't know anything about theirs, and I'm not going to talk about it. Yeah, who here is doing hardware in the loop testing? All right. What are you? Yeah. Okay. So what are you using for that? Yeah. You're using a lot of those things are cool.
So Ricardo and I, we worked at Qualcomm now, but we are mostly using an infrastructure that was created by Foundries before it was acquired, which is based on Lava. Lava is this Linaro project, Linaro Automated Validation Architecture, I think it's like the acronym. It's open source, it's packaged in Debian as well. It's fairly established, it's used by Linaro, it's used by Foundries, it's used by a few other places. Yeah, on CI, right? Foundries had a bunch of like non-Qualcomm boards as well, albeit right now we're mostly adding Qualcomm boards, obviously. We use it for numerous projects. In the Foundries context, it was used for customer workloads, but or for reference images that might be used by customers. In the Qualcomm context, it's more used for validation of Yocto and Debian images. So we have two projects which are public. All the CI is public as well. So I don't know if you wanna, do you have a laptop here? If you go to github.com/Qualcomm Linux, there are two projects that are showing. Okay. So yeah, we have two projects. One is called like MetaQCOM, which is like the Yocto layer that Qualcomm is doing, and it's being tested on I don't know, like 10 different boards at least, or like different board types. And we have like the Debian images, which are tested on less boards because we're still adding support for different boards. It's called QCOM Debian images, and every time we push a commit, it triggers a build, it triggers tests on all the boards. Every day we do a daily build, and then every pull request we also submit the image to see did it regress, did it progress. And yeah, that's what we do. And in terms of, so in other conferences this year, FOSDEM, embedded recipes, I heard about LabGrid. I heard about Board Swarm as well. It's like, I think Board Swarm, I think it's a ROS-based, lower level device access layer that Collabora, Stuart, I think, is working on.
Yeah, I think they announced it at OSS in Denver. I think I remember that.
I think it's more reduced focus, but it's trying to do that really, really well. We're happy with Lava, I think, in general. Yeah, you want?
So yeah, I mean, like, because like we have like Milos, who used to work for Lenaro and is one of the maintainers of Lava as well. So he maintains the lab, and also we use it at Founders before, like, and we did, of course, like we use MetUpdater, we use like OS3, and on every change we do, we also, besides like testing hardware, we also test like updates, we test boot firmware updates and all of that. But mostly now, like the focus is like was saying, like we're leveraging, and we're actually pushing most of the CI and validation that we do like in the public. So we wanted to have, like, for Meta Qualcomm, like all the validation also done completely like there in the public. So like we basically have like a public Lava instance that runs all the jobs, like the boot testing mostly at the moment, but we're extending to cover more like hardware specific things, like that we care about. And then we're also testing our Debian related like builds that we do kind of the same manner. So we're pretty, of course, like Qualcomm does have like their own internal testing mechanisms and labs and so on. But like for this particular purpose, like we wanted to make sure in the way that we had something that is open and that people can, like easily just use and see the test cases and get the flow. And mostly because, like we're pretty familiar with Lava, and because, like we came from Lenaro, it's pretty much like what we heavily use inside.
Ben Webster from Lenaro. We use Lava. Yeah, it's similar to everyone here. We have a couple hundred devices under test for various projects. We do a lot of boot testing, testing for things like system ready, U-boot, Opti, trusted firmware tests, and that sort of thing, as well as doing a lot of boot tests also for Debian. Our big focus recently, of course, has been moving from basically ad hoc test infrastructure, hardware interface infrastructure, to using the LAA or the Lenaro automation appliance. And so, to a large degree, that's something that we're building out slowly in order to be able to more easily do hardware in the loop testing wherever your hardware happens to be, which is kind of nice. So it means that not only can we have a cloud-based centralized Lava managed service that we can tie multiple Lava instances into, but it also means that we can essentially put an LAA at a developer's desk at home, or of course at a customer site, or what have you, which makes it a whole lot easier. But yeah, we of course employ the Lava maintainers, so of course we have direct access to that. At the same time, we also, I want to say that we are actually working at the moment at getting an external co-maintainer that's external to Lenaro, purely to allow more access for people to be able to get things in. It's we're not sure where that's going to be yet, but it's highly likely. It depends. As we all know, being a maintainer is hard, and so it's a matter of talking somebody into it that wants to do it, really, more than anything else. But yeah, basically the ability to connect disparate hardware devices across the world into a single pane of glass through reporting and that sort of thing to make it easier. So the other thing is we, of course, are working with kernel CI and Collabora in order to bring a number of the technologies that we've built over the years, like text tools and some of the things that were built for LKFT and so on and so forth, to the kernel CI world. And indeed, we are hoping that the LAA will also start getting adopted more in the kernel CI space, in order to make it a whole lot easier for people to add themselves to kernel CI in a very simple and...
Yep.
Yeah, that's what we do. Somebody else?
Yeah, hi. So I'm Chris from Renesas. I was involved heavily with CIP and kind of CI. So we run a Lava Lab, like everyone else, which or my team, we mainly use for kernel testing. We do upstreaming. I also manage a Yocto BSP, so we run that through as well. Generic setup. Recently, kind of reset up the lab, so we've got the ability to flash bootloaders in it. Sort of most of our reference boards, you've got to manually flip dip switches, and Path about to do that. So we put some relays on it, and we can do that now. So we can also flash new bootloader stack. And we can do the whole kind of end-to-end testing, which is quite nice.
I guess that's the,
Bit like
yeah.
the LA. So. So on the LAA, is there a Lava worker built into that for each board, or is it? Okay, yeah. Sorry.
With Pull Labs, which is something we're working on and haven't really announced yet, but we can actually put a Git runner on there as well. So we can actually run from a CI direct onto the LAA as well.
Jan wants to know how much the LAA costs.
So the LAA is actually not something we're selling; it's something that we're renting. So yeah, it's a platform that we use internally, and we have a number of companies playing with, including people at Renesas and other places like that. If I'm able to say. But yeah, we use it as a part of a couple of things. It was one of the major things being used as part of LKFT. Also, OneLab, which is one of our projects. Please, it's on the internet already, so it doesn't matter. It's all good. But you may not have seen the case before. That's something that I built, but prior to that, it was just a bare board. No, it provides a lot of value, especially since we all know that it's hard to get disparate things connected with relays and everything else and keep that working. That sits on my desk or is attached to my wall through a hanger, and it means I can pick it up and move it around, and it still works as long as you have power and internet. It's all good. The best part about this is you can give access to people this remotely, and they only have access to your device under test, not the rest of your network, which is kind of nice. I still have it on a VLAN at home, but nonetheless.
Does anyone else want to share what they do? Philip? Or, oh, yeah.
Yeah,
Phil.
I guess since we're doing a bit of self-promotion, might as well mention. So I'm Adrian. I'm leading this OCP track. I'm sure some of the people here are familiar with Open Compute project, which is called Test and Validation. So if what we're trying to do there is kind of create an ecosystem regarding testing various hardware components, which does include like ARM-based stuff and memory and devices, storage, and whatnot. There's some specifications and some other stuff in there. It's software-based mostly, so I guess when people hear OCP, they think of hardware. This is the only one software project in OCP. I guess if anyone is interested in collaborating on making like the testing better in the whole infrastructure. Yep.
What are you testing?
So this isn't, the project isn't specifically about one single hardware component. It is more of trying to design a contract between testing payloads, let's say, and different testing executors, so that every company, say hyperscalers or vendors, they can have their own internal testing infrastructure, but we can share testing workloads. Right. So, for example, reducing a lot of NPI work that happens in hyperscalers, because at the end of the day, everyone basically tests the same things, hardware capabilities.
So, like shared test suites would be a good way to describe it.
Yeah,
or?
that's a good thing. also kind of like certifications and
Okay. All right, Phil, your turn.
Are the OCP test suites public somewhere? Hey.
Can you repeat the question, please?
Are the test suites used for OCP public somewhere so we can take a look at them?
Oh yeah, everything is open source based. Like that's fundamental tenets in order to be able to share all of these payloads in between. So we have like a couple of companies involved already. I'm not sure I can actually mention names right now, but just look up OCP test and validation, and you'll find like the main page.
Philip Ballister. I'm mainly tinkering with LabGrid at the moment so that I can run runtime tests of GNU Radio on actual hardware so that I can check it on ARMs things. Nothing very exciting, but teaching myself how to use a GitLab runner to talk to LabGrid very poorly. It's getting better.
Does anyone else want to share what they do for automated testing? There's only like 3 other people in the room, so.
All right. Turn to face me so I can throw you the box.
Oh, yeah.
Yeah, I can tell the echo is really bad from my side, so I might interrupt myself. So I'm Jan Lübbe. I'm the maintainer of LabGrid together with Ruven, who is now at Linaro. And yeah, we built LabGrid some 10 years ago, I think now. And we also started building some hardware for our internal use, and then later started selling those. So SD muxes and USB switches and relay controls via CAN buses and so on. And recently also some small Linux device integrated to control the test place. I can put the link in the chat. And it's not open hardware, but all the software is open source and you can run mainline Linux on it. And LabGrid exporter. So yeah, this one. It's a bit smaller than the Linaro La. Yeah, so that's it from my side.
Does anyone have burning questions about hardware in the loop testing?
Yeah, so there are a number of, I think, groups doing similar things, but there are like a few areas where I see that there is not yet like emerging open source projects, more like very spread out, like different things. The 2 main things I've noticed are hardware enablement testing. So I used to work at Canonical where we used something called Checkbox. And Checkbox was a test runner with a lot of tests about is Wi-Fi working, is video working, and things like that. And sometimes it would collaborate with the test infrastructure. Checkbox is open source, but it's a bit tricky to run outside of like Ubuntu. It's like using snaps as a vehicle for like deploying the test. And so yeah, this idea of like hardware enablement testing, I've not seen emerging projects. Like Checkbox is only used by Ubuntu. Qualcomm with a public test now called a Qualcomm Linux test kit, which are also on Qualcomm Linux org. But yeah, it's not many, it's not structured, it's not universal. So yeah, I'm looking for like what could be the unified place where we could contribute tests so that we don't reinvent the wheel in many places. And another thing which I find really difficult is once you've got like one device managed by your Lava or your LabGrid or whatever, and you want to start testing something with it, like which is hardware related, you often need some agreement on the test scenario. Maybe you need to, I don't know, capture the HDMI output while you press a key, or maybe you want to have like a Bluetooth beacon and talk to that Bluetooth beacon or some Wi-Fi access point. And again, there is no kind of like reference way of doing that. So everyone is doing their own thing in their corner of the world and reinventing the wheel there a little bit. And I don't know how collaboration would look like in that front, but I could see that as we get to common test, we also want to get to kind of like common definitions of how you're supposed to set up the environment to test for that. So I'm expecting that if you're like maintaining Network Manager or BlueZ and whatnot, or Mesa, or you like to express how the testbed should be, so that any company can set up that testbed and test their products in that testbed and verify that the test scenario works. But we have not come to that kind of like level of maturity. And yeah, so that's something I would like. Maybe it exists and I just don't know about it. Otherwise, I'd love to have a place to contribute to, like kind of like standard way to organize for these things. I think it's missing right now.
So that's exactly what we're trying to build, like a place to be able to collaborate all of these tests, non-differentiated hardware, any kind of equipment.
OCP is mostly data center centric, right? Would you agree, or do you have also like this embedded? Would you see an embedded side as well?
You can just both stand around that. Yeah.
Yeah, so this particular project, which is test and validation, is not necessarily data center centric, right? It can cover basically any kind of hardware, and we've made the spec, the output test diagnostic output spec, intentionally vague enough that you can express multiple types of testing, like functional performance, compliance, and multiple types of payloads.
Are you focused on testing pieces of hardware, or are you focused on testing software running on hardware?
Both.
Okay. Interesting.
Yeah. In terms of hardware, like you can test the behavior, you can test compliance. Like, for example, one of the ideas is for vendors, instead of giving you like a piece of hardware and a document and says, the specification is this thing can do 10 gigabits per second or something, right? Instead of that, you can have an executable unit which allows you to reproduce that claim, right? So that's one of the things that we're trying to cover.
Yeah, because we've never had the problem where you don't get the advertised speed of a peripheral.
Sure,
yeah.
But it would be nicer, right?
Yeah,
than just have like some text.
Yeah. Anyone else have anything related to automated testing? We had a bunch of people walk in, but I don't think they're here for that. Yeah. 4 minutes. Yeah. Okay. All right. Well, any last words?
Thank you for stepping up and running the BOF.
Thank you for talking a lot, so I didn't have to say anything. Yeah, I'm trying to find the guys. Help them set up the thing. One mic.
This basically runs the problem.
Oh, who's just speaking? Yeah, you got it here. I don't think it's because you want to record.
The STLs for this are so in fact my management is not sure about some of the cases, so although I haven't just actually
I think it'll just change to the next one. So,
few wires.
yeah, it's already uploaded. Upload it here, right? Yeah. Yeah. So, it's only one mic though.
Yeah.
I'm just like. Hello, everybody. So this is KDLP expanding the Linux kernel talent pipeline. I'm Dennis, this is Rado, and we both work for Red Hat. So a little background on KDLP. It's the kernel development learning pipeline program / course. The idea is to create a pipeline from university students to industry in the kernel development space. We felt like there was a lack of fresh talent in the kernel development industry, and most of the experts in the field are aging, and there needs to be some sort of replenishment of talent. So, and maybe desire from the younger generation to
also
contribute.
the entry level to contribute to kernel is quite big. The kernel has grown in past years. It's not so easy to get around the kernel source code and the niches of the community.
Yeah, it's hard to get into is the point, and we're trying to establish a way to kind of get people involved from university. Also, universities generally, there's a consensus that they don't really
prepare people for this type of work adequately. So the program began a couple of years ago, like 4 to 5 years ago, as a 4-credit course in Massachusetts, in Lowell, Massachusetts, at a state university, and it was also was given as a free course online. And over the years, it expanded to a number of universities across the world. Partnerships have been established in other cities in the States, in Ireland, Czech Republic, and Israel. So the value that we're talking about with KDLP as it's the pipeline itself, as I already mentioned. Additionally, all the material is open source, so ideally anybody who's interested in delivering this content can take it and improve it, use it to teach, just critique it if they want, but ideally would meaningfully contribute to it in some way. The various iterations of the course and the different universities resulted in 9 full-time hires at Red Hat and at other companies in the industry. This is specific. This is the U.S. iteration. The Czech Republic, I guess there's 2 full-time hires and then 1 in one processing right now. So considerable amount of people that ended up actually working in the field. Yeah, and as mentioned, the course has run at UMass Lowell, Masaryk University in Brno, and San Antonio, Texas, and Technion in Haifa, Israel. So personal connections to the course, I took the second iteration of the free online course, which resulted in Red Hat offered me an internship through which one of the responsibilities was to contribute to the program. Did some content creation, contribution, did some TA work, and some administrative stuff. Then went back to my bachelor's degree and was invited for a full-time position with Red Hat again. Now I'm doing liaison between the different iterations of the course in the US and Brno and Red Hat itself.
And I met with Joel on LPC in 2023 in the US, and Joel is one of the founding persons of the KDLP project in the US. He was looking for a person who can pick up the torch for Czech Republic, and I joined a few of our other colleagues from Red Hat, and we made a new university course from scratch that we teach now in Brno. Yeah, and I work as a project lead for Brno, and I also teach.
So this is kind of the pattern that the program has taken. It started at Red Hat with Joel Savitz. You guys might know him. He would reach out to seasoned kernel engineers, and some people at Red Hat also teach at various universities. And the idea was to kind of come together and use the people that are already teaching this similar type of content, or if find people that are interested in teaching, and kind of just create a community around it.
Makes sense for kernel engineers to teach, as they are the one who are knowledgeable most about their field. If someone is expert in his subsystem, it makes sense to share that information in a consumable way with students.
So yeah, as the program has been going, we've established some issues with how things have been going. It's been going very well, as already stated, but there's some natural hiccups, and we're kind of auditing ourselves in the process and determining how we can improve. Yeah, we'll go through the varying problem statements. So first things first, you have the people, the instructors that are delivering the content. They are specialized to very usually, as I already stated, they're usually specialized to a particular niche or subsystem in the kernel, and maybe they're not the most adequate instructor for like every topic that we're trying to cover, since this is kind of an introductory course that's being offered to kind of get people interested in kernel development. Maybe the people that are signing up to deliver this content aren't always the best for each particular topic. The students themselves it just depends on the semester. Sometimes they're maybe under-prepared in their knowledge base with the content that we're trying to deliver. Sometimes they're maybe over-prepared, and then it's maybe the course is too easy for them. And the last thing is, usually this course is delivered through a university, so their rules automatically apply to the course that we're delivering, and values don't always overlap. So that's an extra thing to kind of consider.
Last year we had a cohort of students that was very knowledgeable. I gave them a presentation about the x86 architecture and paging and CPU internals, and they gave us a feedback like, we already know all this stuff, you don't have to tell us. And this year we have students which do not know what paging is. So we need to be flexible on what we tell to the students, and we never know what kind of depth students like know the hardware or the environment.
So the idea is to generate more topics that we want to cover, and this is part of the purpose of this talk, is to get some insight from the community about what would be useful to add to our curriculum. So we want more topics to kind of make it easier to adapt to varying requirements of instructors, students, and delivery medium, as in the universities. We want the content to be like very modular, so we can adjust to the environment and potentially sort the topics by difficulty, so that someone can just coming in could very easily determine where they can hop in and deliver. Yes. Wait, sorry, can we use the mic?
I just wanted to say I think this is really awesome what you're doing. Which universities are you partnered with at the minute, and is it a big list or?
Yeah, it was mentioned in the previous slide. So it's UMass Lowell, University of UMass Lowell, which is UML. Then there's Masaryk University in Brno, Texas San Antonio, and Technion.
And are you looking to expand the number of universities you're connected with?
Yes, yeah, that's part of the goal of this as well. So we'll have contact information at the end. So we would love to talk. Yeah.
Sounds great.
A follow-up question to that. I think the work you're doing is terrific. I guess I want to know if you have these statistics. You were mentioning that the students who are going through this program end up getting involved with the kernel and industry. Do you know if they're doing kernel development work as part of a company, but are they contributing back upstream after graduation? Because one thing I feel, so I think I do agree that colleges are kind of moving less and less from focusing on operating system core fundamentals, but I still think that exists in universities. But I do think there's always the gap. Well, there are two gaps. One is the level of depth they go into, and then the second is connecting students to the idea of doing this kind of development in open source communities. I was kind of curious about how this program might be helping there.
So I would like to quote a movie that I like. I can show you the door, but you have to walk through the door. The goal of the course is to motivate students to dig deeper into kernel. I mean, we cannot make like full-fledged kernel developers in 4 months. from students. We can just motivate them to be more active and show them the workflow and the basics. Yeah.
Yeah, but in terms of like actual upstream contributions once you're in industry, I mean, it also really depends on the opportunities that you're given on the job, right? So I have a recent upstream contribution. I've been employed at Red Hat for like almost a year. I had one opportunity to do so, and it turned out to be fruitful, but I don't know how. It really just depends on the circumstance. I don't know. I think that would be a good thing to look at. I think we can reach out to definitely all the people that.
Just one follow-up. So I completely agree with those perspectives. On my own time, I try to teach students and focus on kernel development and contributing. I think one thing I encourage the students, even if they go into industry and their industry doesn't let them, contribute as part of their work, I try even encouraging contributions as an individual. I think, maybe just that messaging to students that it doesn't have to be a part of their work could be very encouraging.
Yeah, that's true. I think there's a lot of that's part of. I think that's a good topic to add to the curriculum. Maybe just an overall message, and there are a lot of topics to cover, especially given like what Rado said. You have 4 months. How does it all play out? But I mean, that's ultimately the goal. So. Yeah.
You need to find an intersection between what's practical for the students and what's interesting in those 4 months. So we show them the the work pipeline. We show them how to send mails. We have a mailing list. They learn how to send patches and patch sets. We try to teach them as much of the workflow as possible. And I met a student from the last year. He was working in Red Hat now, and he told me like, yeah, when I came to Red Hat, I already knew what to do. I knew how to download the source code, how to compile it, how to format the patches, how to send them. I didn't need any supervisor to tell me how to do this.
My question's probably be a bit out of scope, but it goes to talk about, like we mentioned, like showing people the door, right? I was wondering if there was any thought about trying to sort of advertise this sort of kernel development to high school students or working with people in local communities, because there also has been like a trend of lesser students entering the STEM field to begin with. And usually when people go into engineering or like comp sci programs in university, they're sort of already aware of Linux and kernel development to some extent as well. So I was just wondering if there was going to be any sort of thought or focus in the future to reach out to students at the high school level.
I feel it like there are very few individuals that would be ready to take on this type of material at high school level. And I don't know if, I mean, maybe, but you have college students coming in that don't really understand the system that way. So.
Right, of course. Like the curriculum would have to be obviously very simplified and very different, but I was just wondering if there was any sort of thinking to make a track like this or something like that as an extension of what you're doing for universities.
Well, that's the goal. We want to create content that should be consumable for several levels of students. And it's open source, so anybody should be able to pick it up and teach at their university or, I don't know, children's home, or I don't know, this high school.
Yeah, I think that's a good, yeah. I don't think we were thinking about going like kind of that far out on that spectrum of knowledge, but I think that's not a bad idea. Yeah.
Yeah, like perhaps something that can be done is like, since like as a community, we could, maybe have some resources or things like that to help teach high school kids about different streams that are in Linux kernel development, and maybe, people asynchronously create their own communities and help with those, using those resources to very quickly teach students about that in the high school level. Yeah, just an idea.
Right. Not sure if we'll get to that slide, but the idea is to create a course that will be focused more for people to create their own course from the source material than for the children. So you can come in and adapt it for your requirements. As we understand, like every school has its own requirements, every group of students, every state or country has their own requirements, time or whatever. So it's material for the teachers, not a source book for students to follow.
Yes, I also had a question about the students that are coming to the program. Do you guys have data on how many students are either have zero kernel experience or zero development experience and they're trying this out versus individuals that are like, oh, I'm already interested in kernel, I want to take this.
I mean, usually the prerequisites for the course are generally like you need to be very familiar with C, and you need to have taken at least one operating systems course, ideally. I mean, usually, at least in the States and Canada, there's operating systems 1 and 2. You should probably be taking both of those. And then by that point, you definitely are aware of what a kernel is, I feel like, at least vaguely. Maybe not.
Depends again on the school. In Brno, the students select the course as a part of a seminar group. There are 3 different groups. It's kind of complicated just because we are not teachers. But there's a loophole we can teach at a university. So the students select one of the 3 different topics. If they do not get into one of the groups they have selected, they will come to us. So we had people who are asking for the Go programming language and ended up here in our course. So they have 0 experience with kernel development, but they are still doing the homework.
Did you have a question too? Yeah.
That's your it's like a question comment. But when I see when encouraging new people to contribute to the Linux kernel, like there are some non-zero number of folks that are technically capable and knowledgeable, can try write code, but they're mentally unprepared to work on the kernel mailing list. So yes, they can write good code, they can make things work, but they also need social preparation of how to communicate in a, I would say, pragmatic environment that most in companies would protect you from. You would not get a harsh review or something like that. And that puts people off as well. So there is a non-zero percentage of potential kernel developers are blocked by the fact that they're not prepared to push through their code. So it would be nice if the project also kind of prepared them.
Probably the way to get exposed to it is by trying it, right? That is an interesting point about the your corporate email protecting you from from getting picked apart. That is an interesting point. But yeah, I mean, ideally, again, there's not much time. Maybe the program can be expanded to maybe 2 semesters or more eventually. Kind of have a consecutive part, and then having upstream contribution be a goal of the course for each student. Or I mean, that's very optimistic, but yeah.
The topic of how to communicate on mailing list, the upstream, is always there in the syllabus, but we sometimes leave it out because students are more interested in technical topics. But it's one of the questions that we would like to discuss here, like what do you really want from us to teach the students? Because those students made up in your companies, they will bring some kind of set of knowledge. So what will help you to put them engaged in kernel development as fast as possible? So I understand it's not just technical knowledge about hey, this subsystem works this way. It's about soft skills and such. But yeah, what can we do to students better prepare for the real work in your companies?
Okay. What's the process for someone who wants to become a teacher and bring this project to other parts of the world is? And my second question is, does it have necessarily to be attached to a university course? Because I think not everyone has the opportunity to attend university, and we have good examples of that in our community. So
yeah, so the entry level to the course is bring a bottle of whiskey. No, just contact us and we will talk. And you can, sure, if you want to teach outside of university, that's great. Part of the motivation for students is that they get credit. It's a 4-credit course, so they will not just sleep on the lectures. They will try to end the course with a success. So I don't know how much motivation you will get from students who will not get a reward in the end.
Okay, but do you guys do some sort of onboarding with the new teachers? Because I agree with him, a bunch of good engineers are not necessarily good teachers.
Yeah, I mean, so basically, just to go back to your original question, there is an free online course. Basically, at least for the US iteration, all the links are available to the public. It's just a question of having a grader, because with the school, it makes sense. Someone's getting paid to do that, they're gonna do it.
And we have the infrastructure as well now.
Yeah.
Yeah.
Well, the infrastructure is at least for the US iteration, it's in-house, so it's a little bit different. But when I took the course, I took it as a free online course, because I mean, I didn't attend the university that it was available at. At that time, there were less students, so the instructors were able to kind of review my work. But at this point, each iteration has from 20 to 30 people. So, and it's very fast-paced. So it's unclear right now. People that are interested in taking the course that I talk to, I share the link with them, but like, it's basically, here's this content and here's somebody that's delivering it, but you're not gonna have a grader. But that would be nice to get that figured out in some way. But for if you want to teach, definitely come talk to us. We have a lot of material, and I'm sure all of it is online as well, so you can join and help deliver the content. Yeah. Okay, we'll keep going in that case. So, I mean, we've talked about a lot already, but second problem is since the conversation was started with reaching out to individual engineers at Red Hat and seeing if they were interested in delivering this course and if they were already maybe teaching something like this, we ended up with content divergence, which we needed to kind of get this program off the ground, and like people had semi-working versions that we kind of started working on together. But in the end, the content is we would like to kind of bring it back in and create a single source of truth for the content from which each iteration can kind of pull from, and according to their needs, according to the needs of the instructors, the students, the university.
Due to the restrictions on how to check schools' work or universities, we had to create a new course from scratch. So we are still teaching under the name of KDLP, but we have created a new course on a green field. And of course, we came up with different topics, how we cover them. It doesn't make sense to duplicate the whole work. So we will now duplicate the third time by creating a new course. But this time we will like to make it more open for everybody to join, the US as well as Brno, and we have more people who are interested to contribute.
Yeah, so all the different iterations coming together and hopefully the community deciding on a common pool of knowledge is definitely a goal of ours. The last thing is scaling. We've been pretty good at it, I would say, in the duration of the program, given that it's pretty consistently being delivered at 3 to 4 universities. But we'd like to expand. And if anyone's interested, definitely reach out to us. The more the merrier. So yeah, want to reach more people, want to improve the quality of the content. Additionally, teaching is a pretty big commitment, but but if you are just interested in guest speaking as well, that's wonderful. We've had that in the past, and it's been, I don't know if Wander is in here, but when I was taking the course, he came in a couple of times and spoke, and it was nice to hear someone that's, you know, kind of telling the students about the specific subsystem system that he works on. He showed some patches, and yeah, it was pretty influential. So yeah.
In Brno, I tried to bring the kernel engineers who are located directly in Brno or in Czech Republic to teach about the specific subsystems they know about. So we had Irka Benz to come and teach about the networking stack. We had Victor Malik to teach about eBPF. We have Carlos Maiolino to teach about file systems. So it makes sense because those people who are the most knowledgeable have the most energy, who can influence the students to get more connected with that stuff. And also the students already have some ideas and have some intricate questions that only the best or the knowledgeable people of the subsystem can answer. So I can teach about, I don't know, like memory management or process management, but if someone asks me a specific question and I do not know, it doesn't really ring with the students. So it's good to be there that the professionals do it, that they can like spread the fire of the energy for the students.
Yeah, and it is definitely worth noting that this is in everyone's best interest. I feel like, you know, it's an important issue to focus on. So yeah, any help is appreciated. You know, got to get more people interested in this stuff. So yeah, just to kind of keep the conversation going, this is a snapshot of our internal model of like what the course is. It's not anything objective. It's just kind of to show you the various kind of skills that we want to focus on. It kind of expands, and this kind of also shows the slight differences in the two iterations that we're like specifically focusing on right now. But yeah, this is just
So we wanted to create an Excel sheet that, first of all, maps a path from students who doesn't know anything specific about the kernel development until a professional godhood level through different steps, and we try to map that onto what we are actually teaching in those courses to find divergence and also to map like where can we more expand, what can be more interesting to students. The Excel sheet is like 50 rows long. We didn't want to show like everything, but just the idea of the thought process.
Yeah, we think it's a good way to think about the problem. It's like where do people start? Where do you expect them to be? And like kind of fill in that scale. So in summary, we want to make the content more flexible, create more of it, get more people involved, be able to have that skill path, a well-defined skill path, and sort the topics by difficulty, standardize the common pool of knowledge, pull that into each individual iteration of the course as needed. Here's some like the questions that we've been mulling over during this presentation. When you see a potential candidate coming in that you're interviewing to come and potentially join your company, what is the baseline set of skills that you expect them to have as a kernel engineer? And additionally, what set of skills would set that individual apart and would make a very good and valuable kernel engineer? These are kind of the questions that we're hoping to ask you. And yeah, so while you think about that,
yeah.
So I had a couple of questions at least. If we start going back to your initial thesis that there is a lack of incoming talent in the kernel community, Given that we have a community that's bringing in about 2,000 first-time contributors every year, I'm curious what you think it should be.
Does the increment in community correlates with the increase of source code or the complexity of the kernel?
Well, that's an interesting question, of course. Yes. How many first time become second time? I have actually generated statistics on that in the past. Some do. You have to look over a period of time, but some of them do their one patch and they're gone, and you never see them again. Any project will be that way. And some of them stick around and become maintainers. So anyway, I didn't really want to poke fun at that. My more serious questions are, one, are you teaching C, or are you thinking about teaching coming in as a Rust-based kernel developer? What are your thoughts on that front?
The question of Rust has been iterated several times, but we decided to leave it alone as it's a very active topic right now in the community. So we are mostly focusing on C.
I do believe that will be the source of a lot of our incoming developers in the future. And we definitely encourage some attention that way. You have all these materials there, open source. I haven't seen any of them in the kernel community itself where we could sure use a lot more nicer documentation. Have you thought about actually working with the kernel community and trying to upstream some of your materials? Because I expect some of them would be useful.
Yes, we did. One of the suggestions was, like, once we are finished with a new course, we would like to make it part of the kernel documentation, either the kernel itself or...
That's sort of like saying once we are finished with the kernel. You're never finished. When you have stuff that's useful, we would love to see it.
Yes, I mean, the problem with the not the documentation, but the teaching material is it needs to map to the changes of the kernel, how the kernel is moving forward. Last year, we gave a presentation about memory management, and I noticed, like, hey, we don't use any RMB trees for VMAs. We use maple trees, so we had to rewrite parts of the presentation. The same goes with scheduler. Thanks to Phil Alt, who reviewed my presentation. So it needs to be a living document. My idea is that someone will be responsible for specific chapters and work with the upstream community and update them according to the changes in the kernel.
I mean, if you have some of this actually in the kernel documentation, you might actually get some help keeping it current. Estimates of how well that works tend to be optimistic in my view, but you would get some.
This actually, you mentioned a good point. This is another thing that I've seen that people buy like Linux kernel books and they study them, or even when they buy a new book, by the time it gets for a publisher to review and post the book, it kind of becomes outdated if you teach very specific implementations. Like if you teach general concept and like critical understanding of a system, like such people could then dissect the new implementation and trace it back. But it depends on like how people learn, because some people say, oh, the book says like we use I don't know, like the example of a bottom half, right? And now there is no bottom half in the kernel anymore. Whatever the new equivalent is. So like, yeah, if you read the Linux kernel device drivers, you will have outdated content.
That's exactly my point.
So yeah,
there are several ways how to contribute. You don't have to be a teacher or anything, but if you want to teach, we would welcome. But you still help us by proofreading the content that we create, or create content, or we do assignments for the students. We try to mimic the workflow of the kernel. So they create patches, they send them to a mailing list. We do code reviews. So if people help us with code reviews, as they are, time consuming, that's also nice help. So you don't have to be afraid. We can try to find you some specific part of the project to work on.
So yeah, I guess Rado, you could probably speak to this one.
So since we are creating a new course and we try to join with the US, the kernel engineers from SUSE were also interested to join. So yeah, we are starting the new course with SUSE kernel engineers. They want to teach the course later in the Prague University on ČVUT. So there will be another expansion if everything goes well. And they have agreed. They are located in Prague, not in Brno, but they have agreed to come to Brno and teach, as we have agreed to come to Prague and teach the part that we create.
So yeah, if you want to check out the material that we have available, this is the landing page for all the different iterations that are ongoing and have been in the past. And our contact information, please reach out to either one of us if you want to contribute in some way and or talk to us after the presentation.
Don't be afraid.
But yeah, so that can be the end of the conversation. But if anyone has any specific topics that, any specific answers to the two questions up here, that would also be very valuable. We definitely had a good conversation so far, but if anything else is remaining.
What skill set makes a good, valuable kernel engineer? From my perspective, and like, by the way, it's like self-promotion. Like my company, Cloudflare, is set to hire 1,111 interns, and some of them can go to my team, the kernel team. So what I've been looking for potential interns is curiosity. It's the only thing that matters, because I kind of believe if a person is interested in kernel development, they will succeed. But like, the problem is that not everyone interested. So it's like, oh, you kind of like, oh, memory management. No, like it's easier to. I had once a colleague. She used to be an iOS developer, turned security engineer. So she always said, why be a regular engineer if you can be an iOS engineer and get 3 times more salary? Then she turned the security engineer and said, like, oh, like, why do be an iOS developer? You can be a security developer and get more times salary. So I don't know if there is, if you can say these things about kernel development, but yeah, but so like the people need to be really curious into kernel development. But if they're curious, I believe they will succeed, because we can teach people on the spot. Help with curiosity, that would be nice.
Sure.
And if you're looking at skills to impart, I would put a real focus on the process side of things, working with the development process. We've had so many episodes of very talented engineers who can create good code, but who are unable to function within the kernel community and how the community works. So anything that you can teach about how that works, how to interact with it, would be most helpful. Added to it would be maintainership skills. Basic repository management, all to actually managing a tree and taking submissions from somebody else. We have a lot of people who come in who can contribute code, but what we really need are people who can take the maintainership positions and do code review. Those are important skills that I would love to see more widely distributed.
That makes sense.
So Dennis, this question is more geared towards you. What do you feel like you got out of the course, and what did it convince you ultimately to do to be able to pursue a career like this?
I feel like definitely like a big part of it was like patch creation etiquette was a big part of it that I found was useful. Kind of more fine-tuned. Like there's a lot of exposure to syscalls and like writing drivers. There's character drivers specifically. I can't say that, I mean, all the topics are kind of more system level, so that there hasn't been like a very, when I took the course at least, there wasn't anything geared to a particular subsystem, right? It was kind of more giving you the lay of the land of how the submission process works and how to like signal processing, I guess, in the kernel. But it's gotten a lot more mature since then. The assignments are very very detailed. But yeah, I mean, I think the flexibility in the kernel was a thing that I really like. The course, when I took the course, the demystification of the kernel was the thing that I really took away from it, because coming into it, I didn't really know much about what it is. I never had compiled the kernel or anything like that. Never written a driver, never written a syscall. And working with it and like making changes to a driver, recompiling the kernel, seeing the effect that it has on like whatever thing that you happen to be looking at, like even just a simple message, simple like log and demessage or something, like that made working with in the industry a lot more approachable. So yeah, I don't know if that answers the question.
Yeah, it does. Thank you.
You talked about having engineers come in and talk about the, like Wonder did. Is there an easy way that people could sign up to know what needs to be helped with, or what could be talked about? Is that a thing?
Like an easy way to sign up to do
like say you
guest
want
talk
on their topic, like say a file systems engineer about that. Like what's the current method you would get those people to sign up?
Just conversations. Yeah, I think if you're interested, then we can write you down in a notebook and then reach out. That's the way to do it right now.
But I believe if you maybe approach them or made a form for people to sign up, it would get a lot more volunteers, because I think people are passionate about sharing what they do.
Yeah, I think adding a page on the webpage would be a good addition. Yeah. Okay, I guess that's it. Thank you, everybody.
Thank you.
There should be
This domestic semester from September to December.
Yeah, we're definitely.
And the got a similar course that teaches me how to compile the Linux kernel modules. But the point is here that there are LPC everywhere.
Oh, you just come around here like do that? Yeah. Question is how to show in universities.
Yeah, just kind of way to just provide an assignment to just have the resistance.
Yeah, so that's a great question. So I think that the best way is right now is to join the organization with Susan and we give you a project and like formate it in some kind of a problem question that we can discuss and see how it goes up.
Yeah.
And it's like a final setting now, we have.
And also another question is,
and then get them this.
maybe Jackson is really kind of new professor and it maybe some
So
new
encourage
structure
that.
report. So
Yeah,
how can they just join this project?
Yeah. The best way is to ask if they want it. Yeah, sounds good. Let's do that.
So use that.
Okay, so I will let you go and change that a little.
Yeah, but the professor is at the
Okay, well.
Then I just think showing more.
Yeah. So basically, as I was saying, I just gave that course. So it was a team that course. So yeah, I just reading graphic devices is the first assignment. And then the management, scheduling for second.
Here's the
Schedule is just create the RT schedule that's module. And this module manage the registers. So, third one is a memory management.
It's tough because you want to control. Yeah, or maybe even place. Yeah, he did it, he's done it. The issues that I'm not making a mistake, last year's part, because we were being how to do it. People that didn't want to not show exactly. When we, point of view, recycle. Yeah. It's true.
Yeah, I think that was the purpose. That was talking to be more state of the union every year. So like use.
Yeah, right, you know, we thought.
Well, yeah, well, there's a lot of times people show up just for that, like, there's the state of Green. What's not in years. Right. What did we get from last year? Thank you for your suggestions last year. Here's how we. Right. They look like, and then you can start doing more metric collections. You're going to try. Granted, there's 2,000 countries a year. Okay, well, the current program is how many people actually do stay on the maintainers, how many people get hired at full-time positions, some paid for their work, right? Because like people need money just for that kind of thing, right? And now to get a better follow-up is like what we see every year is year-over-year increase of how many people get hired at full-time or part-time positions, or even internships. It's like maintains kind of constraint.
Yeah, the maintainer thing, it's a. Foundation. Well, first of all, and that's you guys. You know, for example, it's like in this course, one of the things you got to do is in your
cover comes off, and then it's a standard catch box. If the venue has them, we hide them from the venue. If the venue doesn't, they can be packed into a suitcase. Chris? Only slightly.
Thank you. Yeah, great to see such a great large number of people here. It's despite the late announcement I sent to the mailing list, but it has been on the schedule for quite a while, so cool. I want to first introduce the things we did, where we are with the project, what are the most important next things we want to do, and then I want to dive into a discussion around what should be next, what should our priorities be, and yeah, any questions you might have. I know the announcement that we are doing some sort of lightning talks. That is probably not, that did not work out. We are turning it more into a discussion like above should really be. So, right. So where is the project right now? I think we made some very good progress during the last year. We started doing development releases. We enabled quite a few things, like we have much better interrupt support now in the SVSM. We still need it from the host side, which brings me to the next section already, which is where do we want to go? What are the next important things? From my personal point of view, one of the really next important things, or the single most important thing to get the SVSM more usable and bring in a broader user base is, of course, making it supported on an upstream virtualization stack, which is KVM, which is actually work outside of the SVSM. So, but it's still the most important thing to get the plane support working and upstream. So this is one of the most important things. The other important things target work inside the SVSM to unblock other use cases. So one is bringing user mode support forward to actually finish the move of lots of the feature that the SVSM have from kernel mode to user mode that we currently have already, and enable future services that we want to provide via the SVSM. So this is the SVSM request loop for the SVSM protocol processing, for example, or also the TPM that should move to user mode. This is one important thing. Another thing that is important to get to work on next year will be to give the SVSM a view of the memory state of the whole virtual machine. So to basically implement state that tells the SVSM which page has been validated and which is invalid, and which privilege levels actually have access to a page. Having this will not only fix potential security issues around double validation that we might find in the SVSM, it will also enable some more use cases like SVSM-based live migration. So this is also one of the important things to enable in the next year. But I'm sure there's many more, so I want to get into the discussion now, or ask everyone to raise your questions or come up with your use cases, explain what you are wanting to use SVSM for. So discussion is open.
Jörg, I want to add one thing to your list of work we want to do soon, which is today the SVSM is usable, in particular as a VTPM provider on SCV, SNP VMs. There has been a bunch of work to build an infrastructure for TDX partitioning, but we don't really have enough infrastructure to run it in a meaningful way. And so something I'm hoping we can do in the next year is broader cross-platform support. I'm sure we're going to start with TDX partitioning because it's the same CPU architecture, x86 64, just on a different virtualization platform. But I think there's going to be a lot of interest in moving to ARM as well. See Ravi here, maybe we want to talk about RISC-V at some point, but cross-platform support I think needs to be on the short list as well.
Right, that is also very important to get this moving at some point. So we can get into a discussion about that, how to make this.
And I know one of the reasons it's been slow to make much progress on other platforms is that the only architecture right now that has a specification that looks like SVSM is SNP. There's no equivalent specification for TDX. So even if we had a lot of contributors who are ready to start writing TDX support, we have nothing to fit into. So if we can get other work happening across the community to define, sort of a calling convention and interoperability standards, then there'll be an appetite for actually getting progress on cross-platform. But probably want to keep on the list of things that we're going to try to get done soon.
Yeah. So most of the work needed to be done for non-x86 support is probably introducing the right abstractions, architecture abstractions. I think that's more than 50% of the work that's needed there.
If you're saying that going beyond x86, our code base has x86 specific concepts everywhere. So it's one thing to say we can create the right abstractions for virtualization concepts, but we have inline assembly code all over the place, page table formats, interrupt management, and a lot of very architecture specific things that have to be redone too.
Need more people, more Intel people to come to the meetings. I think Ju and Yao was the guy who actually did the prototype of SVSM.
Well, he did a prototype paravisor, but the paravisor implementation was very specific to a particular point of view for a particular proof of concept. We do have, in the technical steering committee, we do have a representative from Intel. Right. That's a good start. What we have to do is drum up interest to say that seeing this work on a platform other than SMP is important to a user. And then we can find people who, bodies who will want to, or I should say fingers who want to meet keys on a keyboard.
Yeah. Basically, without commitment from Intel, it's an aspiration.
Yeah, and without a consumer, it's an aspiration for a use case. Anyway, I'm not saying we have a problem. I'm saying these are areas that would be great to move into as we find the right group of volunteers. I think we can all work together to make some great changes.
Yeah, maybe the answer to moving multi-hardware architecture is also to factor out the common parts into libraries and basically implement a separate crate, which basically does the ARM side of things, and that pulls in the generic things like, I don't know, memory management and other things to make it boot.
I mean, there are plenty of examples in other source bases of how to do cross-platform factoring. It's more a matter of finding people who are ready to get started. I talk about TDX partitioning as an easy start just because it's the same CPU architecture, but I don't think I see anybody from ARM here, but if there was somebody at ARM who said, I wish I could make Coconut work on ARM CCA. Okay, great. Well, let's figure out how to give you the help you need to get started. Again, it's where the volunteers come from.
Well, ARM does seem more eager, yes.
What's the appetite for, and we talk about ARM CCA, what's the appetite for just native, non-confidential ARM and starting to look at other use cases for the...
Are you volunteering?
I have other things to do first, but maybe.
So the question was about running on non-confidential ARM? Or?
Yeah. I mean, we have some support for non-confidential x86 today, at least for booting up in that process.
Sure, when there's code, and then I don't see a reason not to support it. So we support non-confidential for x86 already. So,
I mean, I think the high level summary I would give is to say, the technical steering committee has I think a fairly grand vision for what it could become. We don't have as an army of developers who are making it happen. So when you say, like, what's the plan to go do non-confidential ARM? There's the, how much appetite do we have as maintainers to accept that code, and then B, who's going to write it. The answer to the first question is, I'd love to see it. So I just need somebody to write it. But that's not my area of expertise. It's not my priority. It's not your area of expertise or priority. So
The use case for non-confidential ARM.
The Coconut project started. This is your boss. You can say anything you want, but I'll keep going unless you want me to. Coconut was born out of the idea that we need to have a small, lightweight operating environment to support the SVSM. And I think what we've come to realize is the idea of a small, lightweight operating environment has power in many places other than just an SVSM. And so where John here is asking, well, what can you do with non-confidential ARM? That's an example of, hey, we've got some ideas of code we like to write that we would like to run on ARM. Confidential is not the important part. It's the lightweight operating environment that's the thing that's really valuable.
I think there's also a question of if you're looking for more contributors, not having to have hardware that doesn't exist yet is probably might help a little, right? So focusing on some of the non-confidential use cases might actually make it easier to get a longer list of scenarios that can bring contributors.
So without the hardware, how do we do the VMPL stuff on ARM?
Well, I think what John's saying is if you start with non-confidential use cases, you can take non-confidential ARM hardware and say, forget VMPLs, just make the thing boot. But the native code, the native non-confidential support we have in Coconut today is single VMPL. It's just, I boot, and there's a user mode they can start, and I can start, making things run. It's the foundations of a lightweight operating environment more than it is the foundations of a multi-VMPL virtual management system. That's, we got hardware for that can run today with ARM. For anybody else?
Yeah, I've seen people on x86 as well that just test that they don't have hardware and just test the things on non-confidential x86 and boot up. It only works for certain kinds of development items, but I think there's some use to that as well. So. You're also interested in hearing about other use cases that people might have on the SVSM and things we should maybe prioritize more that you don't see prioritized enough, or things that might be missing from our development plan that we have. So if you have anything in mind or any questions.
So what's the plan for live migration? Are we does it depend on the planes patches which needs to be in the workable state, and after that it could be done?
Right, SVSM-based live migration depends on two things. One is planes, and the other thing is that the SVSM keeps track of page states itself. So these are the two things that we need in the SVSM. Or also in KVM, of course, because planes is a KVM thing. And when we have that, then we can make a big leap ahead on that. So
for the KVM side, is the idea still for the vCPU? Or there are some other. I remember.
Yeah, it has not been, there's no final design yet, let's state it so. But it's likely going to look like a shadow vCPU approach where KVM basically asks the SVSM to give it a number of VMSAs that it can execute to do the data re-encryption, and also the final part of the live migration where which happens after the VM is stopped and where the final dirty pages are transferred. So if you call it shadow vCPU or mirror VM, I don't think that matters much from the guest side, because it's for the hardware, it's all one VM or one VM context. How we implement it on the KVM side, It's probably more like a shadow vCPU because it's not a full VM context. These vCPUs do not have, what you call shadow vCPUs will not have an APIC, or do not need an APIC, for example. They are just request response based executors that do the re-encryption. So yeah, so that are the design patterns that emerge from the discussion. So.
So I'm just curious, since I'm not as directly involved in some of the Coconut stuff, one of the challenges with live migration is that it's a hypervisor-driven process, right? And it's going to need to basically call into Coconut, do certain things. I don't think there's any other features that y'all are thinking about, but let me know if I'm wrong, that are like that. But how are those going to be architected? Because that hypervisor to Coconut interface, is that going to be something that you want Coconut to define? Like, this is the service that I'm going to provide, and KVM Hyper-V all have to get in line? Or is there some way that we can have a more standardized interface here? For you, an opinion.
You go for the easy questions, don't you? So the first question we need to be able to answer is, what are the domains in which SVSM-assisted live migration is of interest? Because you're getting at the point, in order for this to work, there has to be a particular type of interface between the SVSM and its host. And there might be multiple hosts that need to implement that interface. But if it turns out that there's only one operating environment that is interested in this, that operating environment is based on KVM, it may not be necessary for us to standardize it. So I would take a sort of pragmatic wait and see. We could try to go big with let's come up with a GHCP type standard, and let's go make it work everywhere, and let's publish it, and let's get lots of input, and find that there are a lot of people who are not interested in picking up the phone to answer the questions. So this feels to me like one of those examples of, let's just make something work, and then once we have something to point at, we can figure out who else is more interested. I'll come sit by you.
So, yeah, so I'm good with that, but are there any other features like that where the hypervisor is going to be calling Coconut?
I can't think of any, and in fact, the only reason we're talking about it for live migration is because of the peculiarities of the way live migration is defined on SNP today, that it ends up being the most effective way is to get the guest directly involved. Every other virtualization feature that I can think of, at least, yes, you're right. Page movement and overcommit might be interesting, but those are not examples of features that people have talked about, I think. Yeah. Yeah.
So maybe this is like I'm also catching up on some of this topic after a while. But from what I recall, at least the way I was thinking about live migration with confidential VMs was using something like SVSM or some environment like that to set up, to do the platform negotiation between the source and destination platform, set up the secure sessions, plumb the whatever transport key you come up with, right, for your stream protocol that you're going to use, and then really let the hypervisor use all the horsepower possible, not be limited by the number of vCPUs given to the guest or the SVSM. Why isn't that a model? Why would we need for the actual data transfer for the hypervisor to call into the SVSM and be limited by its capabilities?
Because on SNP systems, there is no other entity other than the SVSM, except for the PSP, which is system-wide, singleton system-wide, bottlenecked and slow. So the only way that you can get reasonable throughput for migration is to have the guest reach in and actually do the work.
The alternative model works for things like that have a TSM on the CPU, like TDX.
Right, right. I guess, David, back to your broader question. Yes, we may envision cases where the SVSM is providing functionality on behalf of the hypervisor. And it's a little bit of a weird virtualization design because typically, you don't want a virtualization design where for the guest to function, for the guest to be subject to the operational constraints of the host, the guest must do the work the host would want done. But if we determine that there are some of those and that those apply, across hosting architectures and certainly across virtualization architectures, we'll invent what we need to invent. Since we don't seem to be bursting at the seams with ideas right now, I'm reluctant to go and prioritize a standards framework by which all this stuff could plug into. But I don't know. People come up with ideas. Maybe we'll need one.
Then let me pivot slightly. So obviously there's the VTPM protocol that, so we're just talking about services that Coconut might provide on behalf of the hypervisor. Then there's services Coconut might provide on behalf of the guest. VTPM being the obvious one. Are there others that are being worked on?
I'm going to ask you to explain the attestation protocol because there's been a lot of work done on that and I'm not paying any attention to it, but that's another SVSM protocol that's been proposed. Can you remind us what that's for?
You mean the service attestation thing we have?
Well,
you mean the SVSM protocol thing or how the SVSM does the attestation?
No, the SVSM attestation protocol that's been defined that the guest can consume out of the SVSM.
I don't understand every part of it. It's basically a per service attestation or an attestation for all services. You can get, I'm not really sure what the evidence is, but you can request individual attestation for individual services based on a hardware attestation report. So that's also part of it. But
right. So what Jürgen's talking about is sort of like a housekeeping thing that says if I've got a VTPM in there, and the VTPM may be modular with respect to the rest of the SVSM infrastructure, now as a guest, I would like to get a report of what VTPM is running. Because there's actually been work done on different types of VTPM implementations. One where the VTPM's endorsement hierarchy is an ephemeral key that was generated randomly and endorsed by the S&P report. There's another version where the endorsement hierarchy is acquired over some back end that is specific to that guest deployment. So now you've got different ways the VTPM can be configured. You'd like to figure out a way to report out what was done. And so if I've got this modularity in the SVSM, I'd like a protocol to define what got loaded. And then
SVSM protocol already defines what the VTPM will report out, and it's basically the public key according to a certain template.
Let's suspend disbelief for a second and say that we might come up with other ideas too. Right? My point is, because it's possible to invent these protocols in a way that can have variable behavior, it's useful to attest them. And so it's useful to have a protocol that attests what was configured. There's another housekeeping protocol is if the SVSM is going to do work, generally, like as an operating environment on top of what the TPM does, you may want to have a record of what it did. There's not so much of an attestation of what got loaded, but like, oh, it generated log messages for something or other. So I'd like to extract log buffers for debugging or performance monitoring or other types of purposes. So there's been a logging protocol that's been proposed so that the guests can go extract log data.
That's what we've been discussing around observability of the SVSM from the guest.
That's what we call it, the observability protocol.
Right. And the other one was storing UEFI variables in the SVSM to make secure boot work for SMP guests. So these are the ones we currently have on the list, but I'm sure people come up with more. So
right, that being an example that the persistent store that's used to hold these NVRAM variables is something that the SVSM is in a unique position to manage and access, not making it a problem for the lower privileged guest. So now we have an NVRAM store protocol. As we move ahead into a world of TDISP, where we know that all the TDISP device management has to be done in VMPL0, there has to be a way for the guest to say what it wants to have done. So we're probably going to have TDISP protocols. I'm kind of contriving a little bit here, but I don't think it's hard to think that we need to go beyond VTPM plus housekeeping.
So the specific problem is that every protocol has to be defined in the spec, so we know exactly what the report will say. And the spec is rather slow moving. It was supposed to be moved to a community basis that could make it faster moving and do what you want.
That's right. I was going to talk to you about that this week, but I'll talk to you about that later. Yeah, there is appetite from the community to get better community involvement with spec maintenance for the sake of agility. We just have to work out, both mechanically and from the standpoint of, the current spec and architecture owners, how we do this in a way that makes everybody happy. But, well, AMD is the owner, and Tom is the representative, but there are other people who are involved as well. We'll figure it out. But it is not a community property yet, right?
Can you comment on it becoming a community property?
I mean, I haven't been too involved in discussions, but I mean, I guess I'd be interested to hear the arguments about that. And I mean, has Tom said, has he given any pushback or anything,
Well, I don't want to throw him under the bus for not being here, but I have heard him give pushback because of the direction of other people at AMD, not him. So that's what we need to get to the bottom of.
Yeah, he basically said it's the usual corporate legal issues thing.
Yes, there are some of those, but we just need to make it a point we need to prioritize moving this forward. So that we can do it. I know you and I can spend a lot of time making progress.
We don't necessarily need AMD sign-off. We could just move the spec into a GitHub repository under Coconut and just say we're developing it from there. But I mean, AMD would probably rather negotiate a handoff. But if us forking the spec could be leverage for you and AMD, that's one good way of actually doing it.
Yes, we absolutely can do that. All I was going to say, if we do that and AMD doesn't bless it, now you have two competing specs for the same surface area, and it's unclear. Now that's a divergent standard. It's not a standard anymore. But we'll figure it out.
I was talking about there's a difference between what we actually do and what we threaten to do, and how we push community dynamics. I was more arguing it from.
Yeah, so we'll get the leverage where we need to.
We just have to look serious, right? Name me one VP of AMD who's watching this or could even find the recording. If they were willing to play hard, I mean, we can play hardball as hard as we get to. I mean, a threat is only meaningful if you actually can carry it through, and we do have the capacity to carry it through with all the consequences that John outlined. But if push came to shove, I'm sure we would. But the point is that we want you to take the threat internally and grease it in such a way that it looks like A, the community wants to do this, but B, there is a danger to AMD if you don't do it soon.
I'm confident that if I spend another 20 minutes with David, we'll have a plan.
If the spec were to move to the community, what does that mean? Who would be approving the changes?
We already have a steering committee for Coconut, so the easy route would be to put it under that steering committee initially and then get them to decide if they want to decide.
I've heard a concern raised that if the SVSM spec was owned by the Coconut Technical Steering Committee, then it would cease to be an SVSM spec and become a Coconut spec. So, I mean, that's an optics problem. Just figure out, I mean, if there is no other community out there that wants to implement the SVSM protocol, then there's no tension that needs to be resolved. And if we find one, then we'll just go figure out a way to get, cross-pollination to make sure that the maintainer group for the specification reflects the right cross-section of interested parties. We know how to do that.
Owned by Coconut, just say it's steered by the steering committee.
Well, ultimately, the GitHub project lives somewhere, and it has a code policy and maintainers policy associated with it. And if it's part of the Coconut organization, it looks like it's Coconut's rules. But we know how to make open source work. Hey, Microsoft embraces open source.
Yeah, I'm sure when the decision is made that it's going to be community maintained, then we find a process for it. So it's probably not the biggest issue.
And I will add, you know, if it makes you or anybody else feel better, right? Tom is a part of that community. And as we've had discussions about, you know, ways we want to extend the SVSM protocol, Tom has no less voice than anybody else. Tom is active in those conversations, and, you know, involvement helps us get to the right place. So I think AMD still gets what they need to out of it. Like James said, it's, you know, corporate machinery.
Steering committee or something, just for show, I'm sure you could do. Oh yeah, you work for AMD now, sorry. Okay, you got it.
Okay, what else are you interested in to discuss?
Oh, Stefano, I see, has joined the conversation.
Yeah, he joined right at 3, so.
Stefano is one of our technical steering community.
Hello.
Ciao. Hey Stefano.
Ciao Tom. Ciao Jane. Ciao John.
He just did. He said hello.
So Peter, who is not here today, wrote a message to our Matrix chat that if anyone has TDA partitioning use cases, please email him and tell him about it. So he's very interested in hearing about the use cases for that as well. Okay, if nobody has questions, I might have one. A couple of months ago, we started to do development releases. Is this something you find useful? Is this something that nobody cares about, or is it, yeah? That's a question to the room, though. Are there any opinions on that?
Stefano, I see your lips moving, but I don't hear any sound. I don't know if you can talk.
Can you hear me now?
Yes.
Great. So I was saying that we started to use it to package SVSM for Fedora. So we use the development release to essentially release the package in Fedora. Not sure can be useful, but yeah, we are using it that way for now.
Cool. I'm not aware if anyone else is already packaging it regularly. I know in a previous job I tried to package it for OpenSUSE, but I'm not sure if this has been picked up since. Yeah, there isn't even a big difference between our normal head branch and the development releases. Development releases are intended to be used by a broader audience, so not only by the people who actually work on the SVSM, but also by people who want to build their stacks. So they are intended to be more stable than the day-to-day branch. In the day-to-day branch, we expect, well, we do not expect, but we accept more breakages if they happen. The development releases actually get some more testing. That more testing than is done for the usual before the usual merges. So For example, one thing that happens for the development releases is that I actually do release builds and test them on SNP and native, and run the fuzzers that we have in the repository on the code base again to make sure that they don't find. That's also the point where I run formal verification before making a release, but formal verification is not actually a release blocker, so it has been broken for the past 2 releases for various reasons. We will fix it hopefully fix it for the December release, which is going to be next week. So yeah, that's roughly the release process. So yeah, if you have any comments to that afterward, then feel free to reach out to me and or to the Matrix chat or to the community mailing list or to one of our weekly development calls. So and let us know. Okay, so since there are no questions, everyone is happy with how everything is going? Or I guess so. Cool. Sounds like we're doing a great job. Good input for our yearly review next week. So yeah. Okay, then if there's nothing else, I also don't see something in the chat. I think we can end the buff early and yeah. Say again? Right, go for a cup of tea. I'll be around for the rest of the day, so if something comes to your mind, then feel free to approach me and talk to me directly. So, and other than that, yeah, thanks for being here. Thanks for the discussions we had, and yeah, see you all back in the community. So, have a nice day. Hey, Stefano.
Bye.
I'm glad that you got up early on your Saturday.
Yeah. It was a pleasure. Have a nice day. Bye.
One of the two locations. There was one that's you said that there's overflow. Yeah. I don't know how was that. Well, okay, so this conference, when I'm replacing flexible size
Hey, we can start, okay? Yeah, so good afternoon, everyone. Welcome to the Risk Control Macro Conference. My name is Fenghua Yu from NVIDIA. So today, we are going to have 5 topics about risk control from Renee, Tony, Babu, James, and me. Because we only have 45 minutes and 5 topics, so each one only 9 minutes. But after this slot, we have a coffee break, 30 minutes. Hopefully we can still take some time over there. Okay, having said that, first the speaker is Renee to talk about the risk control schema, schema descriptions. Renee, could you please take over the control? Hello, Renee? Yeah, you can take over the control.
Yes, I'm trying to find the controls.
Okay, thank you.
I can't seem to find, is it something you can do, assign?
Speaker? So, no, you're the speaker. You want Renee to present. You need to press the present, make presenter. Yeah.
Okay.
Okay, now you should see the controls.
I do. Thank you very much.
Okay.
Hello, everybody. So my name is Renee Chatra, and I am here to raise awareness about some planned enhancements to how user space manages resource allocations via the schemata file. First, just to start, nothing of this is final. you can find the current discussions in the email threads. The latest one there starts with a great summary written by Dave Martin. Sorry, there's an echo that okay. For the other information for previous issues and side discussions about opens, you can find that in the other threads there. So I would focus on memory bandwidth resource allocation, but everything is intended to apply to all resources. The reason is because of new features coming to memory bandwidth allocation. There are two. So the first is to support new control values. The first one, sorry, the upcoming hardware can support memory bandwidth allocation at finer granularity than what the default allocation of percentage base allows. So some of the hardware can look like a range from 1 to 511, for example, and where 1 is bandwidth allocation and 511 means all the memory bandwidth. And on some hardware, the memory bandwidth allocation may be expressed in fixed point fractions, where the fraction number of bits for the fraction is discovered from the hardware. So in addition to new control values for existing memory bandwidth allocation, we also need to support multiple controls for a resource. So for memory bandwidth allocation, we have in addition to memory bandwidth allocation, hardware also support minimum and maximum bandwidth limits to support use cases. How the current proposal looks is to support that by separating resources from controls. So when a user goes to the info directory, the user will find the regular resource there and a new directory, for example, resource schemata. And in this resource schemata directory, there would be subdirectories named for the controls. The prefix would be the resource name, and then the suffix would indicate the new control. User can then find the properties of each control inside these subdirectories. User is expected to start with a file named type that would describe the type, and it would be backed by some documentation that describes what files the user can expect to find in that directory and what the properties within mean. So as an example there, how it may look for the existing memory bandwidth allocation is user can know that writing a control value C must be between the values found in the minimum and maximum files. And then the actual resource allocation written to the hardware is expressed in a formula there. Now, of course, we have to remain backward compatible. We cannot just use these new control values for the existing memory bandwidth allocation schema, and we cannot just take it away. So the current idea is to introduce a new schema, a new control. In this example, it is shown to have been named optimal. So we have the legacy memory bandwidth control schema and the new one that can support more fine granular allocations. The consequence of that is that there are two rest controls, and then they're both backed by a single hardware controller. So a user may see when writing to this legacy control and then reading back the information, it would be reflected by both of these controls. This relationship between controls is not obvious by looking at this schematic file. And the current idea is to express it via the file hierarchy inside the info directory, where the directory the subdirectory would indicate the control, and then the parent directory would indicate that it's an abstraction. So on the left is one example, and of not all hardware supports all controls. So this hierarchy may look different on different hardware. The middle one shows the hardware that company supports minimum and maximum. And then there would be an abstraction of the finer granular memory bandwidth allocation, and then the additional abstraction for the legacy allocation. There could be additional thank you. There would be additional abstractions available. So if REST control wants to have some semblance of consistency to user space, then it may have additional abstractions as shown in the right there. Now, this where user space can see multiple controls that are backed by a single control on the hardware. One potential problem may be depending on how user space interacts with the schemata file. So ideally, user space would only write changes to the schemata file. But if user space, for example, reads the entire schemata file, just modifies the parts that it understands, then it would see different behavior. So hopefully user space like this does not exist. If they do, please let us know. We have some ideas how to solve it that are under discussion. And finally, the backward compatibility with region aware is not clear yet. There may be, instead of a general memory bandwidth allocation, user may be able to allocate memory bandwidth to different regions. Having the legacy apply to all regions seems reasonable, but if the user modifies one of the region's memory bandwidth, it's not clear how to reflect that in the legacy schema. I understand this was really fast. If anything sounds of interest to users or vendors, please join us. We'd like to get this right. Thank you.
Oh, you know how to Hello, Tony. Hello, Tony. Can you control the slides?
I'll see if I can do that.
I give you as a presenter.
Yeah, I'm just trying to work out which button to click now.
Mm-hmm.
Is it one of the controls from the plus button at the corner?
I think he's already presented.
Yeah.
Just the left and right should change the slide. Yeah, you're moving the further, then left and right should work.
Okay.
Okay. Yep. I think I got that.
Yeah. Let me take over. Okay. Should be okay. Okay.
Yep. I think I'm set now. I think I got control. So can you turn off the mic in the room so I can not have the echo?
Can you control now?
Yeah, I've got control. The arrows work. Just need the mic off in the room to get rid of the echo. Thank you. So I'm Tony Luck. I've been working on res control from the very beginning of res control. And today I'm going to go through a little bit of the details of how region aware works on the Intel systems that are upcoming shortly. Renette already gave you a few hints about this, but so I guess it's more going to be background to what Renette was just talking about. So what is a region? The system of physical address space is divided by memory type and topology into ranges, and each range is tagged with 2 region numbers. One region number is for access by CPUs local to the range, and the other one is for remote access from CPUs elsewhere in the system. And one example is that typically the range from 0 to 2 gigabytes is DDR on the first socket. So that range would be tagged with, or could be tagged with 0 for access from node 0, but it will also be tagged with 1 for the remote access from CPUs on other nodes on the system. And that will go through the whole rest of the physical address space. So you might have some CXL memory that could be tagged with region 2 and 3, depending on whether it's local to a particular node or remote from a node. Right now, in the first implementation, there's only going to be 4 regions. There can be quite a lot of ranges, though, so we should be able to describe quite a few systems, but we will not be able to do things like if you have a system that has more than 2 sockets, you won't be able to individually set up regions for access from different sockets in different regions. You'll just have a concept of my local socket and all the other sockets are remote. And this is all going to be set up by the BIOS. The OS gets to live with what the BIOS set up for the region mappings. It's described in an ACPI table, the MRRM table. The patches for that are already upstream, and the values of this all appear in sys firmware ACPI regions. So yeah, here's our example. What we're expecting is that local DDR will be region 0, remote DDR 1, local CXL 2, and remote CXL 3. And if you don't have any CXL, then you won't have a region 2 and 3. And these ranges don't necessarily have to be populated memory at the time that the firmware runs. So CXL hot plug is under the control of the OS. But the physical address ranges that you can map your CXL memory are all reserved by the BIOS and described in some CEDT tables. So those ranges may be empty initially, and then you map in some CXL memory with a hot plug operation. Memory bandwidth monitoring changes a little bit. We have, as before, there are separate counters for each instance of an L3 cache, but instead of having a local and a total counter, there are counters for each region. So you'll effectively be able to count access to your local region or to your local DDR, to your remote DDR, your local CXL, remote CXL. as Renette was discussing just now, we're not wedded to particular names for the events that you'll show up, but potentially it might look something like this, where we have an MBM local bytes, which is fairly compatible with what we have today, and then MBM remote and SMBM local, borrowing a little bit from the AMD idea of calling the CXL memory slow memory, and then SMBM remote for CXL on remote devices. Again, sort of that's up for discussion as to exactly what we'll end up calling those. And again, Renette stole some of the thunder for this with the updated bits of discussions of what's been going on the mailing list. There'll be entries in the schemata file for each of the different regions, and as Renette just described, info files to describe some of the additional capabilities that we have. For instance, finer grain than single percent, and these minimum and maximum controls that allow you to specify, for instance, for some high priority processes, you might set a minimum bandwidth to say, hardware, please do not throttle this below this level. But you can also, on low priority processes, set some maximum bandwidth to say, do not let these processes go above a particular level. The hardware will monitor how stressed the memory subsystem is and allow things to vary around from the optimum value that you set between those minimum and maximum ranges. So when the system is distressed, the low priority processes may be all shrunk down to those minimum bandwidths, and the high priority processes were allowed to keep getting the bandwidth that they want, so long as the system can still maintain the levels that you configured. And all of this is described in a public document, the RDT architecture specification. It's currently at version 1.2 at this URL. Somewhere before the end of this year, or maybe early in January, the 1.3 version will come out with a few extra wrinkles in, but the basics that I just described are all in the 1.2 version. And if there are questions, I can take them, or we can pass on to the next presenter. Somebody speaking in the room, you need to put the room microphone back on again.
I think we're back. Hey, Tony.
Yep.
So I was talking to you, Chen, and this goes back to the naming. Like, we have a pretty complicated SysFS topology for describing the HMAT, and that's all in terms of nodes. We don't try to do local, we don't try to do remote, we don't try to do CXL or slow or these type names, because they're always going to be wrong. Because your CXL can be fast and your DDR can be slow. Like there is no, it's just ranges with performance. So what would break, or what do you think about just doing this in terms of nodes? Yes, there may be a node that has multiple types. That's firmware's problem to solve, but otherwise a node just kind of naturally fits with a lot of other interfaces that we have.
Well, a lot depends on where you want people, or how many steps you want people to go for the work. I mean, I think we've been trying to look to ways that the schemata file will be fairly descriptive without having to then go to other resources. Although we're probably going to fail to some degree on that you'll have to go to the info file to understand a bit about what info directory to look up what some of those things mean. Our original thoughts on this was just to actually call it region 0, region 1, region 2, region 3, which is just a very generic thing, and make everybody do the work to say, what is my region 0? Oh, I'll have to go look in sys firmware ACPI regions to find out what my regions mean. And even there, it'll only tell me what node they belong to and what address ranges they are. And then they have to go and look at the HMAT table to say, oh, this address range in the HMAT table looks like it's pretty fast, so maybe it's DDR, or it looks like it's got very long access time, so maybe it's CXL. I don't know there's really a very good answer to this. I mean, we would like to have something that is not super system specific, so that if you're on an Intel system or an AMD system or an ARM system, you'll have similar kind of setups to be able to, so you don't have to rewrite all your upper level software to say, oh, I'm on an Intel system, it looks like this, or I'm on a ARM system, it's completely different. I have to have a completely different set of management tools to go and work it. So say the discussion's open on exactly what we'll call things. If we can come up with something that makes everybody happy, I'll be very surprised. If we can come up with something that everyone can live with, that'll be nice.
Tony, as you were describing kind of that walkthrough and this desire to have this work everywhere, it kind of sounded like you were supporting Dan's idea, because nodes sounds like the thing we all have in common.
We do, but the Intel hardware doesn't quite support nodes. As I was saying, we're not going to have enough regions to be able to describe bandwidth in all the different traffic between different nodes. Regions are quite expensive in hardware because you have to have counters for every RMID within every region. So if you say, hey, we want 8 regions instead of 4 regions to describe this system, then suddenly you have a massive number of extra counters available because you need hundreds of counters per region because you have hundreds of RMIDs. Yeah, we're ultimately going to have to compromise a little bit on what we would like to have and what we can actually support in hardware. Yes.
Hello? Well, Tony, yeah, sorry.
If there was a question, I didn't hear it in the static.
We're out of time. We have to move to the next talker or next presenter.
Okay. That's Babu by the look of it.
Can you guys hear me?
I can.
Okay. Okay. Who is going to change the slides? Is it me? I don't know. Okay.
Try your left and right arrows and see if you've been given control.
Okay, yeah, I can see that. Okay. This is Babu Mugar here. I work for AMD, and I'm going to talk about a few features which are coming in AMD systems. So I'm working on that right now. So I'll talk about that. Okay, so key announcements for the next. There is a echo. Can you guys switch off the speaker? Okay. Yeah, I think it's fine now. I don't know. Sometimes it comes and goes. Okay. Okay. I'll continue. So we have recently added assignable bandwidth. Yeah. Bad echo. Okay. Sometimes. Okay. Yeah. Looks good right now. All right. So we have added ABMC support. That's assignable bandwidth monitoring. Okay, or MBM event we call in resource control. So we have increased number of counters from 32. It was from the original, the first generation where it supported. So we moved to 64, and there is no change for that. So it's already taken care with CPID automatically detects it. And then there is we call global memory bandwidth allocation. So it's MBA, and it is basically extension to MBA called Global MBA. And then there is a privilege level 0 association. So I'll talk about that. So as you guys know, AMD has we have a multiple CCX and CCD architecture. So if you have to, MBA feature enables users to set bandwidth limits individually on each domain. So each domain is either CCX or CCD here. So this can cause problems because in a system where application runs on multiple domains, we really cannot control how much bandwidth it's going to use, because normally if it runs on both, it's if you need two domain system, if it runs on both the two domains, so it will be addition of limits on both the domains. So it can use that. If application runs just the one domain, then it will be the limit for that domain. So it can lead to underutilization and overutilization some cases. So we needed to have a control over that. So we have added GMBA support for that. Basically, it provides option to set the ceiling for group of domains. Basically, you select which domains you want to run the application and make them as we call it them as a GMBA control domain, and just set the limit for that. In that case, what happens? So if it runs on one domain, maximum it can use is the limit for the GMBA control domain. If it runs on both the two domains, also it will run with the same limit. So it cannot exceed GMBA control domain limit. So the changes are actually straightforward here. Basically, we'll have to add a new resource, GMBA. I call it as GMBA, and there's a mistake here, GSMBA. Basically, the same thing applies to CXL also. So we'll have two new resources type added, and there is an example I have given here. In this case, the domain 0 and domain 2 are combined together and made as a GMBA control domain. So the other domain, the limit doesn't apply to the other domains here. It just it basically overrides MBA limit. It takes GMBA limit applies here. Any questions on this? Next, let me go to the privilege level 0 association. This is another problem we have seen in, I think it is probably generic for all the vendors. So if a class is aggressively throttled and it moves to kernel mode, the kernel operations also aggressively throttled. So basically, we don't have a separate that kernel as user mode limits. We cannot separate that. So it's both the limit set for a class will apply user level as well as the kernel mode. This can lead to performance bottlenecks and hinder forward progress and cause delays in system under a heavy system load. So for this we have added a new feature, privilege level 0 association. Basically, it allows user to specify a class and RM. Either you can class RMID with the execution level 0, and you set the limits for that class. So when enabled on a hardware thread, when the thread enters privilege level 0, transactions associated with that will be automatically associated. I mean, it will basically limits for that thread will be use PLGA class or RMID. So we call it as PLGA class or PLGA RMID. Otherwise, hardware tool, if that is not the feature is not enabled, then basically hardware thread will be associated with a class and RMID identified by a PQR association register. We call it as PLGA PQR association register for this feature. So we can basically, what feature does is it gives an option to user to change the limits on user mode and kernel mode. So if it's identified an issue with the for the performance. So I'm making changes for this right now. So we'll have to add a new resource control group. It will be called as a PLGA resource control group. So we'll have an option to enable PLGA group or disable, and also assign CPUs. Basically, it will work as work as a resource control group, but only it will be this group will be used for only PLGA. And there's in a system there can be only one PLGA group. It cannot be more than one. And still have to figure out a few things, whether we need to support a task-based association. So that is still had to be worked out. So I'm looking at that. That's all I have. Any questions on this one?
So that group is special because you name it PLZA.
Yeah, that's correct.
Okay.
The limits, limits, whatever you class limits set on that will be used for the kernel mode when an application moves to the kernel mode. So the limits will apply for that whatever class limits you're setting for the PLJ class. It will only apply for when the application move to the kernel mode. It can be useful for VM.
So Fenghua said we needed to switch to James.
All right, that's good. Thanks.
Has that turned the microphone back on? Excellent, right. I don't have any slides, so I should probably say something like opinions of my own, not my employer's. I don't want this to be a status update because that's boring. And instead, these are some ABI things that have been a bit tricky for MPAM, and they result in hardware features that aren't supported. I will skip everything about covering control formats, as Renee has covered that already. And I've got things fall into two categories of hardware features that can't be exposed. Things that are easy to add, and I'm aware the obvious thing might not be the best thing, and it might not work for everybody, and things that are, things too short, things that are a little bit more invasive. And hardware exists for all of this. So the big obvious one is KVM support, which is currently ignored. All MPAM hardware can do this. Ben Horgan's looking at producing a series that does everything we think we need to be able to do, but there are lots of trade-offs. So likely there'll be a fair amount of debate about how much should or should not be visible. And the principal problem is there's some emulation work that needs to be done either by the VMM, something like QEMU, or KVM in the kernel. And typically neither project wants to carry that code. So I'd love to hear from any other architecture how they would, perhaps hypothetically, implement virtualization. So if we can, we come up with only one way that KVM needs to interact with res control, and maybe we decide it doesn't at all, and we do that all in user space. Another thing, so second thing on my list, it's come up on the list from Punit at Qualcomm, has pointed out they've got platforms with monitors on the L2. That's easy to add, and that's probably the right thing to do. But adding new events makes me a bit nervous. And the reason I've seen a platform where the hardware people couldn't describe where the counters were. So one of the things in the back of my head is, where should we put the threshold of too hard to reason about for events or perhaps controls that people might want to add, but it's going to be very hard to express to user space what exactly that's doing. So I think any interface should be tied to stuff that is already described in ACPI, because then, well, it's not a new problem, or it's not a problem we're trying to solve. Third thing on my list, most MPAM platforms I've seen have monitors on the memory controller, not the L3, and res control names the events as if they're part of the L3, at least in the enum, and the domains come from the L3. So there's some fairly complex code in the MPAM driver that tries to spot when the topology is the same, and then it repaints the domain IDs to make them look like the L3. And that's also that existing software can use the existing interface. And Fenghua is going to talk about CPU-less memory nodes, which is the obvious kind of platform that suffers when you do this. I had something about minimum bandwidth controls. So currently the MPAM driver generates one format from the other, which means you just get a static offset of about 5%. And Renee already covered a better way of doing this. I think in the past I've mentioned the IOMMU support, so a way of labeling traffic with a closet and an ARMID. I have some patches, and I think last time I brought this up, Tony thought there was a cleaner way of doing it. Currently, that's all in CPU hot plug locked up hell. So even the old way I had of doing it doesn't work anymore. I mention it because I've not seen a good use case for managing cache structures inside the IOMMU. Labeling traffic, yes, but cache structures within the hardware. So I think we should leave that alone unless somebody's got a use case that shows performance differences from doing that. Otherwise, almost at the bottom of my list, MPAM's got 3 types of control that we could add to schemata. And there are platforms with PRI or PRI, which is an integer priority, bigger is better. CCAP, cache capacity, which is a fixed point fraction of the cache that you'd like to use, not the same as the bitmap that we currently have. And proportional stride, which is like a weight, how often you get a chunk of the bandwidth. And the reason for bringing this up, PRI and proportional stride are probably not going to be attached to the caches. So what should we use as a domain ID? Attaching controls to the things that ACPI already describes might work, but how do we tell user space that this is NUMA PRI and that one's L3 PRI if you've got 2 that are the same? So we don't get confused between platforms if people build different things. And I think it would be good to consider this for any new schema that are added. Today's edition, there was another talk earlier today about an MPAM platform with a different number of closet of the system cache. So it was something like 16 in the L3 and then 2 further out in the system. Currently, the driver just says you get 2. The MPAM's architecture, so the document from ARM that describes how it should work, has got a way of dealing with that, which is a feature called int part ID. And I intend to hide almost all of that in the MPAM driver. I don't think that's something we should expose to user space at all. I think it makes it very hard to think about control groups and monitor groups when you've got something that doesn't fit. And the plan is to drop controls that can't be aliased and reduce the scope to hide the effect. So the impact on that to res control would be a mount option to say how much aliasing you're doing. And as I'm going through a list, just for the sake of mentioning, I've not seen any platforms with the memory bandwidth bitmap that MPAM defines or the cache associativity controls. Please get in touch if you have a platform with either of those. Any questions, soft fruit, heckling? No, okay, move on to the next. Oh,
hold it.
Yeah, and I'm from Qualcomm, and probably we're in the same presentation of what we did in the morning for the system cache for the MPAM. And is this some of the things you talked about is patches are out or you are working on it, or I was not able to get that.
Okay, yeah, that's the status update I didn't give. So what I've been working on is feature parity with Intel Z on AMD parts. So it's only existing things in the interface that res control has that are being supported. I don't have any patches for the int part ID support, which I think is what you're going to find the most interesting. There's been some traffic on the mailing list. I know Dave Martin was looking at doing this, and I think there was somebody from Huawei who was looking at it as well. So there's some sort of thinking about how we might go about supporting that to try and keep it in the npam driver, keep it out of res control. But there's nothing, it's not the current thing that I'm trying to upstream, which is just feature parity.
You want to ask? No. The second question is that is there any of this you plan to move to npam FB, because some of this you need to do it on the MCU or
Okay,
SCMI?
so those listening along at home, npam FB is a firmware interface to the npam hardware. So instead of using read-L, write-L to access registers, you send packets to a microcontroller, and it sends you an interrupt back when it's done. The plan is for all the controls to work in the same way. The difficulty will be the monitors. So the files in res control, that should work because they are always accessed from process context, so you can wait for that interrupt. If we do something like perf support, that's not going to work because you won't be able to wait for the interrupt in the contexts perf calls it in. So that's my warning for people doing npam FB. Otherwise, it should be transparent. So the accessors that go out to access the hardware registers, they just look up whether to send packets to a microcontroller or just access it directly. So you should get everything for free.
Thank you. We are very interested in FB part.
I didn't quite follow your comment about the IOMMU. Are we talking about npam SMMU v3
yes.
port? And were you saying you had patches, they got tangled up in some CPU hot plug, and you're not sure they're worth doing at all? Is that what I heard?
So I think Tony's view was the way it was exposed as ABI wasn't particularly clean, and there's better ways of doing it. I have patches in the extras branch historically that did this. So they exposed something in the tasks file that named IOMMU groups by number, which is the existing structure Linux has, and let you assign them as if they were tasks moving around in the system, and you could, that would put them in a control group by closet or part ID. So labeling traffic coming from devices, I think we should support. I think if you've got an NVMe and a network card both trying to destroy the system bandwidth, you want to know which one's which. It's the structures in the IOMMU. So it's walk cache, it's TLB, and things like that. I think there are hardware controls for those, but I haven't seen any numbers to say somebody's done some experiments that says, oh, this is really worth supporting and exposing to user space. I suspect it's marginal, but there's no data.
Thank you.
Okay, yeah, thank you. Yeah, I'm running out of time. So right now it's coffee break. You are free to go, and I continue to talk about this for another 9 minutes, and probably we can discuss further. Yeah, but you are free to go, okay? Okay. Okay, talk about the CPU-less memory node. Basically, it's CSL memory, but ARM, we are doing the different things as x86. x86 just now, Tony and Babu talk about the CSL as belong to L3, so it's in the same node as CPU. But ARM has a different design. The CSL memory can be a standalone NUMA node. There are no L3, no CPU. So but it has a npam control on the node. So that makes the difference eventually. So when we discover this memory node, it's a NUMA node. So kernel understands that ACPI table, then understands that CSL memory as NUMA node. For the npam, it has another npam ACPI table to get the IOMMU address to access the MPAM registers for this NUMA node. Access the MPAM, MBA and MBM registers on this node is through MMIO register. So since there are no CPU, no L3 on this NUMA node, so we cannot, the schemata right now is, if you check the spec and just now Tony and Renee talk about that, it's always cache ID. When you control and monitor that memory bandwidth, it's always cache ID equal to a number, right? To allocate the memory bandwidth. But we don't have the CPU on this. We don't have cache on this one. So it's, we cannot identify this CPU-less node by the cache ID, So we need a NUMA ID to identify this. So you can see we're going to have the new line for allocation. I call it MBN. N means NUMA, right? The NUMA ID 0 equal to a bandwidth. NUMA ID 1 equal to another bandwidth. Here is not cache ID, right? So that's a difference. That's a new schemata format. For the monitoring, it's the same thing. Currently, we have the monitoring per L3, but we cannot, because we don't have L3 on this NUMA node, right? So I propose this new allocation, new monitoring for the CPU, I call it the CPU-less, the last line is called CPU-less, followed by a NUMA ID. Then has the MBM total bytes. We don't have local bytes, there are no CPU, right? So that's another imbalance thing for this monitoring. We only can monitor total bytes. And it's based on the NUMA ID, not by the L3 ID. So that's another new change. So the discuss for this is, I propose these two changes. One is the schemata MBN, the NUMA ID equal to bandwidth for allocation. Another one is the monitoring. It's also based on the NUMA ID and only has the total bytes for the CPU-less node. So yeah, so basically the quickly brief explanation of the CPU-less, we have two changes. So if you have any idea, any question, we can discuss. I think I still have some time. Or we can discuss anything else, the previous presentation.
That would be very helpful for the RISC-V the RISC-V CBQRI specification, because we have the concept of bandwidth and it's not tied to any sort of like specific thing. So it could just be a memory controller like this. So I didn't know where to put that because it's not a cache, right? So this would be quite helpful for the RISC-V spec as well.
Mm-hmm. Yeah. Yes, thank you. Yesterday I wanted to your presentation about the RISC-V risk control, right? Very helpful.
Yeah. Are there patches for this, or is it just kind of a concept right now?
Only concept. I'm doing tests right now.
Perhaps a different example then. I have patches in the extras branch which do this, but in a different way. So it adds a mount option that changes the MB domain IDs to the NUMA NID. And that's user space opting into this being different. It is just a different way of doing it. I suspect the good reason to add a new schema is if there are platforms with both, and if you wanted to try and control them individually. The way SNC looks, if people were to do that, they might need to have both.
Okay, yeah. Yeah, I didn't discuss this implementation with you. That's my personal implementation. So probably we can discuss this offline in details, yeah, after this. Yeah.
The other thing to note is adding anything like this means res control then has to go and take the memory hot plug lock as well for domains coming offline and offline, wherever it takes the CPU hot plug lock.
Yeah. So you also need a mount option to turn on this, right?
For the approach I took, yes. For what you're proposing, you wouldn't, which is probably a good thing.
Okay. Yeah, for my proposed ways, I don't have the mount option. So automatically detect the CPU lines NUMA node, then add this new line for the allocation. Yeah, and the monitoring.
The approach I took was thinking, if there's existing software trying to use this, and it only knows what MB is, and it's not particularly tied to the domain IDs, you could maybe say that it was safe for this. I don't know of any such software.
Yeah.
So we could just declare it as not existing.
Yeah, and also this proposal can mix the legacy CPU ID allocation based on per L3 allocation and also the CPU lines allocation. So they can do both in a mixed platform. Like some NUMA node has a CPU, some NUMA node doesn't have CPU, right? So yeah, so probably it has two lines. One is for allocation for the legacy. One is allocation for CPU lines NUMA node. Yeah. Yeah.
Anybody
If
else
you
with any
have any
questions?
other
Otherwise-
question about the previous presentation, we can discuss now as well.
Otherwise, Francois, I'm going to keep digging. So.
Yeah, I got a question for James or you. Yeah, so I'm asking that we got use cases for for the remote memory, which means that we can access the memory from one node to another node, and which is another machine. So we're adding another MMU to access the memory on the another node. So I'm asking that. What do you need to do to use that? This is a use case for the CPU NUMA node. But so shall we add in something in the memory control group or on the new added MMU or something like that?
I don't know if anybody's listening at home. I'm not sure I completely follow what the system looks like. If you're describing it to Linux as being NUMA nodes, then it's already creating structures in sysfs. And there's tools like LSMem that were NUMA nodes. I think you should do this. If it was something stranger, say if it were CXL was the reason for doing this, it might be worth doing something different if it's not being described as NUMA nodes. I don't know enough about what you're describing.
Yes, it's so. Yeah, it's pretty similar to CXL. Yeah. So I'm not sure. So how to do that in the CXL and the use cases here?
Okay, if it does look like CXL, it might be worth looking at AMD's SMBA schema entry, because that might fit exactly what you need. In which case, we should do that because it's not new.
Yeah, SMBA is very similar as this one, but they design as not a CPU-less NUMA node, right? So it's still CSL memory bound to L3, bound to a CPU node, basically. So even like a lot of different CSL memory device memory, so they all bound to some L3. So it's in the upstream kernel already for the risk control. So it's called the SMBA, right?
Okay.
So Babu knows this
Okay.
more than me.
Thanks.
Yeah, but here we have different implementation. The CSL is doesn't belong to any L3, doesn't belong to any CPU node, right?
Yeah.
So it's standalone.
Just a quick question on that. Where does the throttling occur for this memory bandwidth allocation? And then the monitoring to be able to understand what the limits are, and then the throttling.
For which system, sorry?
These systems that Feng was talking about now. The nodeless ones.
What's the question?
CPU-less, sorry.
So you are saying about the IOMMU, who control this memory bandwidth on this CPU-less node?
Yes, so a user may use this schemata to set some bandwidth limits associated with that NUMA node. So I'm curious where that monitoring is done and that throttling is done. Where in the system?
Yeah, so because this is MMIO address, the register, right? So basically, the for the x86, we have the per L3 control. So it's on one CPU node, right? But this CSL memory node also has a MPAM related control registers. Any CPU can access those MMIO registers. So any CPU actually can control this MPAM on the CPU-less node.
Oh, no, I mean the memory bandwidth itself. So when something runs on a CPU and it maybe needs to be throttled, where does that throttling happen? Is it, sometimes it just happens like right after the L3 miss, it understands that it can't go further. And I think that's why it's often associated with the L3. So I'm wondering the system, when it enforces these bandwidth limits, where are these bandwidth limits enforced on the system?
Yeah, go ahead.
I can describe how ARM systems typically do this. I don't know how Fenghua's platform does this. The interconnect standard for ARM systems has a signal called CBusy, and it uses that to put back pressure up into the system to say slow down. So I think you're describing having the MMIO registers in the memory controller. So it would be the memory controller saying slow down for a particular part ID or clause ID. And that would then go back to wherever the requests were coming from. And it should track that by part ID or clause ID. It could be the L3 that's slowing down. It could be the CPUs. This stuff isn't defined by the MPAM architecture, so it can change. But that's what I've seen from the interconnect standard. Does that answer the question?
Yes, I'm curious about the scope of that throttling. So if the scope is being throttled at the L3, for example, then it may be similar to the other architectures.
I think that can definitely happen, and I think it can also, if you're, I think it can also get back to the CPUs. So I've seen some trick they had for resetting that when changing tasks. So it definitely gets back to the CPU as well. I don't know an awful lot about how this works. It's a hardware design kind of thing.
Thank you.
Yeah, I want to say like this is the remote, right? So it's not local. So any CPU access to this NUMA node, CSL NUMA node, is always remote. So probably that's, does that answer your question? So it's not like belong to L3, because before I work on x86, this memory always goes through the L3 between, we do the monitoring allocation between the L3 and the memory, right? That path, we do the allocation monitoring. But here, the ARM looks like different. It do like this one, not between L3 and the memory, basically. At least this is remote, right? It's not local. Yeah, is that okay or?
Yes, thank you.
Yeah, any other question? Actually, I have a question for Babu, but I'm not sure you can speak or not. But just now you mentioned that zero, that one is, yeah, this one, privilege level 0 association, right? So whenever it go from user to kernel, from kernel to user, it switch class ID and RMID. Is that the idea
Yes,
about
that's
this?
correct. Yeah, that's correct.
Yeah. Yeah, what's the overhead to do this switch? Because for x86, it's access MSR. The cost is very high, right? Before when we designed this with Tony and Renee, actually we consider this, but overhead is so high. Go enter and exit from the kernel when we switch cross ID RMID. We cannot stand that overhead.
Yeah.
So you
I
have
mean, this is done at a hardware level. So basically, the OS doesn't switch it. I mean, it's automatic done at the hardware level. So you basically set up PLZA class, and you set up the limits on the class, and hardware automatically switches it. So we don't do at context switch, but if you have to support task-based association, then we'll have to do when task moves from one CPU to another CPU, then there is a cost for that. So I'm working on that. But if there is just a CPU, there is no, we don't have to write any MSR. It is taken care by the hardware automatically.
Yeah.
Just to comment, all MPAM hardware can do this as well. And similarly, the cost is free because you don't need to context switch the register. You just set it up in advance.
Yeah, I think it's free. It's only 1 to 2 cycles. I mirror that. But I mirror the x86, it write to PQR, associate MSR,
yeah, so
a few hundred cycles.
If you
so
have
that's a big difference. Yeah. I'm not sure AMP, yeah. Yeah, here it's not a context switch, right? It's just changes the PQR associate MSR when between the user and the kernel. So if you do that frequently, I'm not sure.
I think they're not rewriting the MSR. They're just saying the value that you use depends on the currently ring level. So if you're in ring 3, you use the value in PQR-ASOC. And if you're in ring 0, you use the PLZA value.
Correct. Yeah, that's correct.
Oh, okay, I see.
But the task-based association, we need to write, change the MSR. So that part I'm still not very sure yet, so I cannot comment on that. But if there is, it is set up automatically in the one time, right? It's only one time setup, most part.
Okay, I see. Thank you.
It seems the interface among L3 cache ID, the interface is unsuitable for because ARM hardware counts the transition passing through MSC. So the interface is unsuitable for traditional NUMA node.
Which slide? Which slide are you talking about?
27.
Okay. Oh, okay. Yeah.
Interface among L3 cache ID. This interface is unsuitable for traditional NUMA.
Yes. Yeah. Because traditional is monitor. It's monitor memory bandwidth, but it's memory bandwidth monitor is between L3 and the memory. So it's memory belong to L3 basically, right? So we just use the cache ID, L3 cache ID, and monitor that cache ID to identify which part we monitor, right? So it's per L3. But CPU-less, they're not L3. So that's why I said, okay, we need a different name. Yeah.
Okay.
Yeah. Thank you. Any other question? Yeah. Oh, by the way, for the RISC-V, do you have any other new features like need a RISC control change?
Well, they're very like abstract in nature, right? So we just have abilities to control capacity and bandwidth and monitor capacity and bandwidth. So those are pretty abstract in terms of what they could be. I mean, the only implementations I'm aware of are doing it for cache controller, so like the capacity in a cache, or for a memory controller controlling the bandwidth. So I'm not seeing any other like resources being controlled, but like, you know, when we were working on the spec, we discussed it could be things like interconnects or TLBs, but like I haven't seen anyone doing anything with that yet. So, but the biggest challenge with doing the implementation for the RISC-V spec was that, yeah, we have the idea of like a memory controller could be handling the bandwidth, and it is unrelated to cache. So this is quite helpful what you presented, I think, in that regard. And then I guess we'll see what people do, because the spec is very generic in terms of what you could do with it. So it could present other interesting challenges, but the memory controller is the biggest one, I think, right now.
Okay. Yeah. So do you expect like any risk control interface change when you port to RISC-V?
Well, I think just in terms of what resource would fit the memory controller. So I think
Okay,
what you've
so
described, it would be good.
Okay.
In terms of the
That's
cache, I think the cache is pretty much, we don't have the other, it's just like a bit mask. That's all it is. So I should correct myself. We have a block mask, which is like a bit mask, but then we also have something called C units, which is capacity units. So if the block mask is describing like the cacheways, then the C units, the capacity units, would be like the number of cache lines. So let's say you only have a few number of like resource IDs, then you could have additional entries where it'd be like the same resource ID, but you would change like the number of capacity units, aka like cache lines that like different access types could use. So it allows you to basically differentiate further beyond just like the capacity blocks, which could be cacheways, versus like a more granular these capacity units, which would be something like a cache line.
Yeah.
So that's probably a little bit of a quirk that you know, would present additional issues of how to represent that as a resource in the schemata, because it wouldn't just be like the bit mask, it would also be like the bit mask for like the less granular, and then the more specific would be like how many cache lines can you use within each way. So there is also that in the specification. So that would, yeah, pose a challenge as to how to represent that in the schemata. But I think the implementations I'm aware of right now is just using the like bitmap to like the bit mask to represent like the cacheways.
Okay. Yeah. Thank you.
And then I guess for bandwidth, the other thing is there's the idea of like there's reserve bandwidth, which is similar to like MB, like how much, like what sort of how much of the reserve bandwidth can you allocate? But then there's also the idea of a weight associated with the unreserved bandwidth. So for the bandwidth that's not reserved for specific resource IDs, then you can also set for each resource ID, like how much of the unreserved bandwidth can it use? And it's sort of a sum of different weights. So that would also be another thing that we had to think about how that would be described in the schemata. So there's a few additional like quirky things like that.
Yeah. Okay. Yeah. Thank you. Any other questions?
I just have a quick comment for, I think if I understood James correctly, there was a need to express more events. Please take a look at some recent changes in support of package scope events, in support of Intel's application energy telemetry. It started to separate the meaning of events. The ID is not associated with event IDs on the hardware anymore. So maybe take a look at that. That separation is it's not so cleanly associated anymore. It's starting to separate, and we may just keep moving in to support those L2 events.
Okay, thanks. That comes from my comment of sticking it with the L3 to to try and keep exactly as it was at the time. And if it's changing, that's probably good and easy for platforms. Thanks.
Yeah, I think next group is coming, so we're running out of time. Yeah, thank you very much. Yeah, okay. Yeah, thank you. Thank you, Renee and Tony and Babu.
Thank you. Bye.
Mike.
Just like people are going to do more. Maybe we can just smooth things because of okay, right? Like a page on the floor. Oh, it has to be nearby power. All I'm thinking maybe there are here. Yeah. Oh, all we can put the table here and move the chair to the table. And not work.
Put the table where?
We can put the table closer to the stage.
Yeah, but where's the power?
Power.
Do you see any power?
I have see power. Slurry power.
Oh, here. Yeah, there's power here.
All right.
Here it is.
I think I would just let you.
What do you do for the buff? What do you want to do for the alpha?
Alex and the general said that it's maybe too technical.
Oh, the other thing I was really we have to read the products, the comments of the build headset.
We're talking about the reduced test. We made a new product. And all the officers of our topic can be reduced to comments of that.
Okay. No, there's no size for this.
Well, did you make have you make a slide? I may have one. Semi-portable. Oh yes, let's figure it out. Let's figure it out. Maybe we choose to by taking it downstairs. No. What kind of plug is that? US. Yes, US should be. US should be here. I don't have that. Ooh, not running, not running. Yeah, we probably. We don't have any presentation. It's supposed to be like office hour thing. Yeah. Go ahead. Thank you. Yeah. I will. Let's start it in about 2 minutes. So wait for people to join from the break time. Then we can ask if when they're there. Yeah. This is Rust office hour. You're right. Yeah. It's downstairs. I want to. Get up here.
Screenshot, you want me to try from my laptop?
Just go up there and do it. I mean, yeah, but you have to like make one group. You don't like to become one.
Can you,
I mean,
can you ping Miguel and Alice and Sulit? Ping Miguel and Alice and Sulit?
well, I don't think we have anything to do with that at the moment. So they don't have that. It's fine. Just, yeah, we're gonna start it. It's more stuff. Yeah, we're gonna start it. We're gonna start it. It's fine.
Hello, everybody. We have some technical issue about showing the Rust office our side, but other than that, I think we are good to start it. Oh, sorry. I was having second thought. So, please share my screen. It's just the Rust office hour, so it's just blanket. So everybody knows that this room is for this. Otherwise, I'm sharing my. Okay, then it's fine. It's fine. Don't worry. Yes, thank you. As I said, that the Rust office hour has started. This is the opportunity we want to offer so that if you have any Rust-related problem or you have any inquiries you want to ask, and we do have some backup topic if nobody is if everybody being shy. So other than that, please raise a hand if you want to. Don't be shy. Just what do we want to discuss for the Rust office hour? It could be anything. All right. Yeah, we do.
Miguel said a day or two ago that trying to avoid the use of unstable stuff. But what about like one of the things I noticed is we don't have a way to do likely in stable Rust, right? The likely, like if likely.
Yeah.
Do we just wait?
I guess the current plan is probably just wait.
Okay.
So I think my understanding, Miguel is not here, but my understanding by not using unstable feature is just make them stable as quickly as possible before you use. Okay. Yeah, Gary.
Yeah. So for specifically for but likely like this stuff hints, we can always do is that we can say it can because it can be implemented as an operation, right? You can always say if we detect if the compiler supports certain features, if it does, then we use these hints. If it doesn't, then we don't. So that's one approach for hint-like features. Obviously, that doesn't apply to general features overall, right? Another thing is that likely and unlikely can be implemented in stable Rust because there's a code attribute on functions. So for example, if you call a function that's code, basically LVM will treat all the code paths that lead to it as being unlikely. So in that sense, you can already implement likely and unlikely features today in stable Rust. It's just that it's not in the form that the C looks like.
Yeah, I tried that in a different project and it didn't quite give me the code generation I wanted. But you're right. You can define these in the kernel crate and update them over time. Maybe that's good enough.
I think in general, likely unlikely as it's currently implemented, like similar in C is not liked by the Rust project because for example, if you do a match, you can't use the likely function or like function like syntax to denote which of the branch is more likely. So I think that's why the language, the Rust language team want something like basically doesn't like the current approach as is, like a function call that turns a boolean into a boolean. Right?
Gary, could you see if there is an issue with tracking for this unlikely in our GitHub? If you can find that.
Yeah, I'll check.
We already have I think we do have. We already have like an issue tracking all the wanted feature in our
Well,
GitHub.
we have list tracking like 100 or more features that we want. Oh yeah,
But
we
I
can already
think
put it there. Well, no, actually, where is it? No, it's actually not there. Is it? Oh yeah, it's already tracked.
It's already tracked?
Oh, great.
Yeah. There's also a Rust tracking issue. I'll just put it in here.
So then I have a question. Why is that not disabled? Is there any blocker for that likely and unlikely? Harry, do you know?
I don't think there's any blockers. It's just like all other features. It needs a discussion, a design meeting, and somebody write an RFC for it, essentially.
So I have a
And-
question, a simple one. Where is this tracker where is this GitHub repository that you're tracking all these features? Because I haven't heard of it before.
So it's basically if you go to this particular issue.
Gary, do you see if you can present?
I can't. I don't think I can present. No.
Okay.
But basically on this issue number 2 on the RESTful Linux /Linux, this is like the meta. This is like the meta issue where it tracks tracking issues and then individual tracking issues track other issues. Well, actually, some individual issues track Rust language tracking issues. So there's a tracking issue of tracking issue of tracking issues. But you can find all the things that we want from there. It's a very, very long list.
Okay. All right. Thank you for the question. Do we have any other question or anything? Otherwise, you guys are welcome to play this game, which we just set up.
I am a Rust newbie. Are there plans for the USB class device abstraction? Do we have anything for that? I was looking to convert some very simple USB drivers as a method of teaching myself, but discovered quickly I was lacking some things.
I can answer this one because I've been the person working on this. So the plan is to have enough support to be able to write USB skeleton.c, a Rust version of that. For the time being, you can basically register a USB device. That's all we have.
Okay.
If you want to contribute to that, you're more than welcome.
Okay, cool. Yeah, I didn't want to be reinventing any wheels that may already exist somewhere. So like it looked like USB class devices, like the herb infrastructure didn't exist either. So like I have to sort of do each of these pieces. Is that roughly accurate?
Yeah, there's a plan for all of this. It's just that so far I'm the only person working on it, and
Okay.
I didn't have the time with the other stuff I've been working on
Sure.
simultaneously.
Okay.
Yeah, but if you want to contribute, then feel free.
I may ping you. Thanks.
All right.
So now that the end of the Rust experiment is over, is there any change on the policy that every subsystem has at the moment with Rust and, dealing with, decisions that maintainers are actually doing? Does this status of that changes any particular subsystem or?
I feel like that is a Miguel question, but
That is a what, sorry?
That's a question from Miguel.
Okay.
But maybe Alex want to answer that.
Nothing along those lines came up during the maintainer summit. So if that's going to happen, then it's going to be later, but I don't think so.
Do we have any other question? Great, thank you.
I was wondering if, or in terms of implementing network protocols and things, so SKB, APIs and that sort of thing, is there any work going on with that that anyone knows of?
How? I do think there's.
So probably the easiest way to check is to join the SULIP and search for SKB and stuff.
Yep.
There's been many people asking about it and expressing interest, but I mean nothing reached the lists. I know there exist abstractions for socket, which is like different but network adjacent, right? Network related, so you can like connect to stuff from inside the kernel via Rust. But it was a while ago, so it probably needs work to be rebased.
Okay, I'll have a look.
Yeah, any other thing?
Just want to say, in general, we really recommend joining the SULIP thing because there's tons of help and really good archives.
Do we have any other topic? If no, we do have some backup topic we can do, but I feel the setup is not to allow at least myself to share the screen, so it's going to be challenging to do like some stuff. Let me check the list. 1 second. So
I have a question. Is there anyone here who did not engage in Rust in their subsystems who are thinking about it? I'm curious. Anyone who's like, yeah, a little bit. If or maybe the.
Well, it's networking related, so yeah, depending how it looks like SKBs are a pretty big amount of surface area to be able to get something going. So, quite sure whether we could sort of just jump into it.
Yeah.
Yeah. My longer term goal was to try to get pstore written, but I knew that there were so many things hooking to it. I was going to start easy with USB. So I sort of have a longer plan to try to see how much of pstore I can move in there, just because.
For the unenlightened of us, what is pstore?
It's the persistent storage. So it's for like crash handling and other things. So it'll write crash dumps into a persistent RAM area, which will survive reboot and then show up in like in the pstore FS, which gets exported. But it's like there's VFS bindings. There's like all these little pieces that I know don't exist yet. But I would like to, because it's sort of a self-contained subsystem that has really distinct, easy, like I can validate the user space visibility. Like I can do simple testing, and it touches a lot of core things in the sense that it needs a bunch of that, but it itself is not like critical to the operation of the rest of the kernel. So it seemed like a nice place to do another one of these things. But again, it's also a replacement project, so it's also not a super high priority.
Yeah, there were Wetson wrote VFS abstractions. I think there are like a few kernel versions back now, but there has been interest in the chat for like I believe a student. Someone rebased them, I think, recently. And I'm also interested in rebasing them and getting them up.
Yeah, that because it's like it's an implementation of the pseudo file system pieces. So you have to like the non-FS stuff. So it defines its own hooks for all sorts of things.
Okay, cool.
I mean, what's the most complex part of what did you call it? Pcache?
pstore.
pstore. I mean, you could do similar to binder and have just the file system in C and everything else in Rust.
Yeah. I'll have to look at it more closely. But I thought I was like, this is my cheat. I'm like, that one looks complex. I'm going to start with really peripheral edge thing like USB. Oh no, I don't have what I need.
I think
I hope
VFS
it
one
won't
of the
be.
things that gathers like wide interest. So perhaps that can be the next area we focus on, get VFS findings.
I really hope we can get that like next year. VFS would be great.
Yeah, if anybody wants to implement file systems, we have binder.fs you can replace.
Let's talk.
To ask what is binder.fs special compared to other file systems? What is binder.fs special compared to other file systems?
I mean, it's kind of similar to debug.fs and stuff like that. I mean, it's basically just a place for, it defines a few files that you can open to use the binder, and there's also a binder logs directory that lets you extract information, kind of like debug.fs. So it's not really that special.
Okay.
Is there a reason it's not based on config.fs or sysfs?
Probably historical reasons.
So maybe the next implementation in Rust should, use one of those if it makes sense.
But then the user space has changed, right?
Yeah, I mean, we have a user space API.
You don't want to get into Google's user space stack to change that. I guess.
But if it fits, right? Then and if you can make it fit without changing the user space API.
Yeah, that's true.
Then it would be like a lot codeless.
Nobody has any topic. I do want to have a very open topic for maybe Alice and Joseph. So there are people, I guess, asking about async usage in kernel, Rust async. So what do you guys thought on it? Async Rust? Async Rust. So my question is like, what do you think would be a good fit for the async, Rust async in kernel? And is also, that means we need to implement the async runtime. And what would be ideal async runtime?
Well, let me start with a question in return. Can you mention some things that run in the work queue?
Okay.
And then we can analyze whether they would be a good fit for async.
I mean, there's tons of stuff that would be good for async. Like basically all device drivers are written as hand-implemented async state machines, right?
Are they?
At least the ones I look at in Block. They are processing I/O requests at different stages, where the I/O request encapsulates basically the state.
So what kind of event would I block on?
You would block on start mapping the DMA. When that's done, you get a callback like to continue processing. Then you set up your hardware to do the I/O, like do the whatever it is. Then you wait again until you get maybe an interrupt or pull a queue and it's done. So I think it's a really good fit. The problem I ran into the most is, in my mind experiment, is some of this, like the context is not the same. So you run in process context and then you come back and you're in interrupt context or whatever, right? And there's no good way to hook that into the Rust async model.
So they don't use like threaded IRQs. They just do it directly in the IRQ.
Yeah, but I mean, I guess you could get it threaded, but I think maybe your latency will suffer then.
Well, I guess if you use async, you probably should be exclusive in process context, at least to begin with.
Yeah.
And also on the async topic, back when we are out of tree, Western did implement async runtime in the kernel. It exists, and this is one of the things I recall. Killing capture spin lock, like lock rule violation inside that runtime, because that's the first thing that killing catches. But it does already exist, obviously based on very old kernel and out of tree.
I think it would probably need a lot of rework, right?
Oh yeah, that's definitely true.
I mean, writing a runtime isn't necessarily so complex. It's more figure out like what are the actual things that you're going to sleep until happen that are a good fit for async, right? That's I think is the hard part.
I mean,
because like usually the model is that you like
A web
call
server.
some async function which goes up and starts some sort of background operation, and then when it's done, it calls the waker, which schedules the future to run on the work queue again, right? And we kind of need something else that has the same structure where you kick off some operation, and then when it finishes, you spawn something on the work queue.
I mean, I think a lot of I/O operations work like that. Probably network as well, right?
So one of the things that's implemented in the original async out of tree driver is the echo server doing HTTP. Not HTTP, just TLS. Sorry, TCP. So networking, like if you want to do echo server, TCP echo server.
TCP echo server.
What?
Echo. Just you send me something, I send something back.
I/O.
Echo.
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 Yeah.
Got it.
So so you could imagine things like if you are, say, like I'm not saying we should rewrite WireGuard, but like if you implement a new VPN protocol, that could be something that you might want async, for example.
I mean, we had a networking. Okay, go ahead.
Well, go ahead. I have a side thing about async, but
I said we had somebody from networking who was interested in Rust. Like, does the model I mentioned come up at all in networking?
I think for drivers, you could do something similar, kind of almost similar to like the Embassy's model of, you interrupt is the waker, and then the main process is just running, waiting on the work queue there. For network protocols, yeah, I'm not quite sure how that would fit.
I mean, the thing is, if you go the route of running this, all the like trigger the thing directly and interrupt, now suddenly your async future is running in the interrupt, and it's kind of.
Well, no, the future is running in process context, and you just wake that. The interrupt does a tiny bit of work and then wakes it. Then just running process.
Yeah, if you just have the interrupt wake up something in a K thread or an arc or whatever, then that makes more sense.
Which is similar to driver models anyway.
Okay, I mean, you can make the waker wake callable inside atomic contacts, but it just need to call the work queue to schedule the thing, right?
Is a question down there, or a hand at least?
the other thing I wanted to point out, from using async in other projects, one thing I'm kind of worried about with async and Rust in general is the size of the generated futures. Rust doesn't do a very good job. Rust C today doesn't do a very good job of minimizing the size of that, right? Seeing that certain values are dead at await points, and I think some of this is fundamental or maybe very difficult to fix within Rust.
It's a compiler expert behind you.
Oh, great.
I have a patch for that.
How does it work?
So there are two problems with the async, let's say async layout algorithm calculation, let's say, is that it's not being very smart. If a value stays alive across 2 points, that the memory slot of that value will be promoted and reserved for the entire lifetime of the future. and second is the capture. The capture is the biggest problem. So I have had to work on the second point, and after that is done, we will move on to fix the not so smart part of the calculation, so that we will overlap the let's say memory reservation as much as we can. The challenge now is that we're touching some rather archaic code in the layout computation, and that requires some experts to review it, and we are kind of short of hands for people that know that stuff. But we are working on it.
Would that be like a blocker for getting started in the kernel, or would you say like just do it and wait for the improvements?
I
It just makes the
prefer
future
to
out-
get the
Sorry.
Garrett, yes. Oh, okay. Let's go with my perception. So I prefer to get the capture case to fix, because combining futures are very common in a way that you pass in another future and you apply transforms to it, and that input future turns out to be captured value, and that we have, with that we have doubling or exponential growth of async future size, and that could be a problem.
Yeah.
But I suppose this will be fixed. This is my goal next year, to get the patch land. At least we will feel better about this overall problem.
Cool.
Yeah, I have some points to add to that. So, so for a reason why the future sizes are big is currently there's what Rust does is that it basically lower futures into a state machine, and then with a predefined layered with all the variables being inside that layered, and that is done pretty early. It doesn't really make use of a lot of lifetime information available. So the mirror does have this information. So in theory, it could compact the stack frames just like how LVM does things. So there's no theoretical issue in implementing that. It just needs to be implemented. And then another thing is that future sizes is not necessarily limited. Like when we generate large future, you don't have to put it on stack. You can allocate memory and then put it there. So it will be bad because it means more memory consumption. But it's not necessarily a blocker in using async in the kernel.
On the first point, using lifetime information, that's the thing I was most worried about. Is that I don't think that's really possible, because you can get a pointer to something on the stack, or well, that ends up in the generator in the generated future, and you've lost the lifetime information, but the pointer, the pointee is still the memory is still alive until the end of the scope, and like you could call pointer, core pointer from ref, and the lifetime's gone, right?
Lifetimes can't affect code gen, or
Right.
they really shouldn't. So
yeah, so that's the one
use
I
the
noticed.
scope.
So
I don't know how you fix.
It has storage live and storage dead information, and that's usually tied with scopes, because there are Rust currently is very conservative about anything touching lifetime. So basically, if you take a reference to something, then it will treat the storage to be alive until the end of scope. So this is the one thing that Rust currently
But
doesn't do very well.
I think that's visible behavior that Rust can't change. Like you can't say, oh, the reference is no longer used, so it's dead here. So the storage that it points to can also be dead, because you could have gotten a pointer. You have to do like escape analysis to see if the pointer could actually have been,
No, you just use the scope, right?
Yeah. You have
At the
to
end
use
of the scope, the destructor runs, and then it's gone.
Yes.
And
yes.
that's it. You can't eliminate it earlier.
Right.
I think
Which
LVM
I think
does
is
some
problematic
analysis.
sometimes.
I think LVM does some analysis and will reduce the like lifetime of a variable earlier, so it makes smaller stack sizes. It's ultimately something that's dependent on the memory model. So unless the the exact memory model about pointers and provenance is like narrowed down, then Rust-C would be very conservative about any of these optimizations. So any of the things that depend on this would be depending on getting a memory model out. And I don't think that's a short-term thing that can be handled. But at least storage, when storage is dead, it should be able to reclaim things. Storage dead, I mean end of scope.
All right.
So more generally, like this issue with the futures being large. So I mean, my experience in user space as the Tokyo maintainer is this is not something people complain to me about ever. Like the only times I've ever heard about this issue is when people in like the Rust for Linux community come to me and say, hey, there's this issue on the issue tracker that the futures are large. But I've never actually had anybody tell me, hey, this is actually a problem I ran into. And people do tell me they run into other problems. Like we have issues like, oh, this mutex is really contented in our issues, right? Please go shard your timer. And so I'm not so worried about it. I mean, maybe on some embedded device where you're super memory constrained, it's a problem. But in like other applications, it has not been a problem enough for them to complain to me.
I guess if you've got a heap to put it on, then yeah, it's not a problem generally.
So, and also with like our in-place initialization feature, in the future, we could in-place initialize the future and then there wouldn't be any big futures on the stack, right?
The future itself will still be quite big, but yes, if it's on initialized in place on the heap.
The future itself will still be big, but you can put it on the heap and then it shouldn't be as big of an issue, right?
With the in-place initialization, I was wondering, does the optimizer often avoid the copy anyway there? So it will actually initialize in place?
So in certain situations, the optimizer does not optimize it away. And then it first constructs it tries to construct a 1 megabyte array on the stack and then move it into a box, for example. So that can definitely happen.
And that happens for futures at the moment? Or
depending on the context.
So let me give some context in here. So in the Rust compiler, box new is very special. If you do a box new, the allocation can, so because things are evaluated in the order you write the code. So the box new would need to happen after you've created the future. So in theory, it's always you create the future, you allocate the box, and then you move the future into the box. So the future needs to stay on the stack. But box new is so special that it can allocate things first, move things onto the stack, and then basically the compiler assuming box new and then freeing the box is a no-op operation. It doesn't have any side effects ever. So it can make this special optimization. If we use kbox, this is not true because our kbox is not the Rust box. So it doesn't know that you can allocate and free without having side effects. In kernel, if we use kbox, because it's not special, we need to use pin initialization, which makes the order explicit to compiler. You always allocate the box first and then move things into place.
Okay, right. That explains things, yeah. Thanks.
Which one? First hand.
As the side note on the Tokyo, I think when I use Tokyo, I'm happy with giant futures. I don't care. It's when I'm not using Tokyo that I care. So that's probably why you don't hear about it. Yeah, embedded space. That's kind of.
Okay, but those people using Tokyo, sometimes they also measure their memory usage and publish blog posts, and then they are very happy that their Rust app has much less memory usage than their old Go app, for example, right? So I don't know, man.
My side of the story is that people noticed it. So when their service start crashing in production as Stack Overflow, and did they, for some reason, wrap this feature in a box or something, and it start working, and they forget about it, and they never complain, which is sad.
Any last discussion topics?
It's not the last question, but I just want to add some my observation on the work queue versus async case. So currently in kernel, when we use work queue, and if we're waiting for some event, we just make that work thread wait, and then if we still use that work queue, it will spawn a new thread. So that is something, if we have the async picture, that's something we can optimize. I just want to mention that.
Yeah, I mean, what async will give you is that you can give back the work queue thread while you're waiting.
Right, yeah.
That's like what you get.
Okay, I think that's all for today. Do you want to wrap it up, or do you want me to wrap it up?
Thanks all for attending.
Thank you. Yeah, he needs to know. I never do that something. And also, why does the screen sharing doesn't work? Yeah, screen sharing. I in my laptop, let me bring it up.
Well, yeah, screen share is one of the things you need to give permission for on your laptop, usually.
I just want to share this. I have a.
Well, Macs are the worst for screen sharing, so it's your fault.
Okay.
You have to enable something in the Mac security sessions to allow screen sharing to work.
Okay, then I won't do that. Maybe.
I don't know what they are though, but I know everybody with a Mac has trouble with screen sharing. That's great.
done and just hang out with something.
Oh, just go ahead. Go ahead. Sorry, I didn't know you were waiting. Okay. This thanks for everybody to stay until now. It's going to be a very simple thing to discuss in this path. It's about helping like establishing how you can install and use Linux kernel memory model. And Paul did that path like 2 years ago. I thought it's maybe good if there's new people join to the kernel community and wondering how you can use that to. So it's going to be a very hands-down session, I would say. It's just going to share how the tool is going to be installed, and I hope that everybody can see like this is you can find the slides on the website. I just uploaded, and then let me know if you have an issue. Install this, and we can go through any questions if you have for the memory model. If no, then we can use this to discuss something else as well. Take a mic.
I think you all heard me, but for the people online, I was just asking how many people wanted to actually install on the laptop. The guys online, I'm gonna have a hard time helping, but we got at least one. You sure you don't want to? You got a laptop there, you should install it on it. Not that hard, it's easy. Secure in what sense? Unless you type your secrets into a litmus test and feed it to it, it won't steal your secrets.
Yeah.
But if you have corporate restrictions from installing unapproved open source projects in your things, and the approval doesn't include that, then you may have to, or I don't know. All right, so yeah.
Okay. So we have one people volunteer to install the tool, or that's what her? Okay. We are just waiting for you. Let me know when you are finished.
No pressure. No pressure.
No
We're waiting
pressure
for you though. Okay. Yeah. All right. He's giving it a try.
So then the question for the rest of the audience, are you already using the Linux kernel memory model, or you are using some other tool to find the bugs in your code? Who want to? Yeah.
I have never used it, and I'm not using anything like it. So I'm here to get an introduction into what it is and what we might use it for, really.
Okay. All right. Thank you.
The installing it from distro is a little bit faster than actually building it. So when you're doing it, that's a good way to start. Let's see. So Srikanth needs that slide. One option would be leave it up there. Another one would be to get the slide to him so he can look at it and go through it. And then the rest of the people, we could show what it can do. I assume you got some slides later that do that.
But we won't have like 1 or 2 slides for the yeah. So I cannot share my screen, so that's kind of problematic. Yeah. Otherwise, I will just show like how you use the tools. I'm trying to figure out.
So I'll just kind of voice over what the thing is. So the point of the Linux kernel memory model
is to do the moral equivalent of a full state space search on small
well,
examples.
it's,
So you
maybe
we'll get an example of litmus test here at some point, but you have a bunch of variables. You have an initialization section where you can set the initial values. If you don't, they default to 0 like C. They're like global variables. And then you have a set of processes. You can name the processes anything you want as long as the first letters are capital P and they're consecutively numbered from 0. All right, so we're going to have him show us what he's doing while he's doing it so we can get the full thing here. It's even better. In any case, so you've got some variables. They can be initialized or they're 0. You have a set of processes, and not, I've got some that have like 19 or something, but the more stores you have and the more processes you have, the slower it goes. This is the moral equivalent of full state space search. So on a good day, it's merely exponential complexity. On a bad day, it's undecidable. So what happens is you give an expression at the bottom. It's a logic expression. And what it does is it goes through and tells you whether that logic expression is sometimes, always, or never satisfied at the end of the test. And the logic expression involves your global variables. You can also define locals in a process and look at the final values of those things. And so the use of it would be if you are worried about some bad outcome, you can put kind of the core of your code. You have to have small things here. This is formal verification, and small is feasible. Okay. And so the bug you can put as the expression, and then it'll go and tell you whether that can happen or not. That's kind of so you can ask yourself, if I do this, have I sufficiently synchronized it? It knows about mostly atomic operations. The Linux kernel games them quickly enough that it's hard to keep up, but it has the ones that have been around for a while. It certainly has those. It knows about locking. It knows about RCU and SRCU. It does not know about some things you'd like it to know about. Again, when you're doing full state space search, life is hard. Okay. As a result, you have simple variables. There aren't structures. You really can still make a linked list, but it's a linked list that only has the pointers in it. You can't put anything else in there besides just the pointer. It doesn't have a memory allocator or a free, and so you end up doing things like having a variable and setting to 0 where you would have freed it. So check if it's 0, then if you get a local variable that ends up being 0, you've got to use after free button. Is the trick you use there. Loops don't happen. You have to unroll them, and of course, if you unroll them too far, then you have a long wait. Look at that. We might be having something happening, or might have a thing on there. And it doesn't have functions. You can use macros, CPU macros, to get that effect to some extent. But again, if you make it too big, life is going to be hard. And I get stealing.
This may be a somewhat naive question, but you said does atomics, unlocking. What about sort of memory barriers and that aspect of it?
Knows about full memory barriers. It knows about the SMP WMB, SMP MB, SMP. It knows about SMP MB after this, a few things like that. Yeah. It knows about load, acquire, store, release. It knows about read once and write once. It will yell at you if you have a data race, if you just do a normal store to something and a normal store so that they could be concurrent, it'll yell at you about that. So it has its limits, but within those limits, it's pretty serious. So it looks like if you want to see this, you have to grab your laptop and log into BVB and look at it. I'm not sure why this is, but sometimes we use workarounds. You do have to do that. Yeah. He's just done the first step. Okay. Okay, so he's got the instructions on. We'll get enough screens here. And with enough screens, you can display anything. All right. We're up to 2 people. Oh, 3. You're installing it? Very good. We got 3 people doing it. Very good. Oh, and James is doing as well. All right, we got 4. This is good. We got 5. Do I hear 5? And when you get done in the first step, it'll tell you this eval something or other thing. You need to remember that because it needs that to be able to find the pieces of itself. At some point, you will need to do its eval $open and -- switch default. Okay. It has dependencies that you need to pull in. You should be able, if the package is there, it should work. We can handle a fair version back. I can't remember. We changed recently, but that was okay, a year ago. It seems like yesterday. So as long as you get one within the current year, you're good. And if you have to use an old one, you can just run your kernel back to what is it, 6.0? If you yeah, 6.10 or something like that. Yeah. So just if you're stuck with an old version that the current mainline doesn't work with, just run your kernel version back always. Be in GitHub tool 7. Sorry? Oh, what we're doing is, at some point, do we have somebody actually sharing their screen? Okay, but if you get on DBV yourself, you can see it. Okay, so something else we need to do. Okay, yeah, this is fine. This is fine. Good. We should probably automate this. Problem with there's a problem with the BBB. So if you want to see what watch it going on, get on BBB yourself, or you can watch this over this guy's shoulder. Yeah, you can. Or sit next to them. Why don't you tell them which step you're on? Yes, yeah, it's written in it. It's written in LKML. People wrote those mathematicians, and so when we get that pause at the bottom, / //, play down B, or you go /. You're almost there. Yeah, it would help. It would. One. So tell me, say again what you asked. Well, it updates frequently, but the kernel doesn't require a new version. I install it and it stays there for a while. But if, yeah, and then so you can only do that if you really want. Essentially, if you. Yeah, and you got a bunch of limits tests as well. Okay.
So if you finish the first step of all of this, you can see there is a step on the second slide. So basically, you can go to the kernel directory of tools, memory model, and run this command. And the path should be in that directory, in the memory model directory, there should be a lieutenant test directory, and there are a bunch of tests you can try to run in that directory. And here, lieutenant test, and there is either one is fine. This is like all the listening tests we have. Maybe this one, maybe this one. Okay. Hey, you got somebody running that? Can you try? Can you run that? Yeah, but I'm not missing. Well, I don't have the problem, Gary. Yeah, I don't have a problem. So, okay. Well, I think you can just either let me just share my screen. Easier. Share my screen. 1 second. Yeah, but you guys can see that in your BBB. Yeah, and you can see here if you want to take a pic. Yeah. I'm sharing in the conference, so if you log into BBB, you can see that. Give me a second. So I'm going to open the little test I'm run. So if you this is the one. So well, I'm using a slightly different one than you guys previously used. So This is typically what we call the message passing style of the program. So here it's something similar to a C program, but slightly different, has slightly different syntax. So there are two CPU here, P0 and P1, and each accessing two global variables, buff and the fly. So P0 is basically doing set buffers and write barrier and then set flag second. And then P1 will just do a read first and a read barrier and read buff. So this is basically what the program is. And down below there is exist cloud, which is what you want this memory model tool to check for your program. And here it means that on the CPU one, it expects that R0 is 1, and on CPU one, it expects R1 is 0. So this is not going to happen if you have the correct synchronization, and this program actually have the correct synchronization. So when you run the herd, you will see whether this cannot happen. So this is what the memory model tools actually give you the answer for. So let me run that. So it will be no. So instead, based on the memory model, run the following program. It will not observe that outcome. The no means no, and the negative means that there are 3 cases which doesn't match the exist cloud for that. And let's see another thing, probably another program. So as I said, let's go back. So it verified the last exist cloud. This logical expression, and it check whether there will be a case when the both program finished, the R0 on CPU one and R1 on CPU one will be this case. So if you see it, so if you're reading about this, it basically means if this read read the previous write, and can the second read fail to read the above write? Basically means that. Basically try to verify that. And so as we just see, the answer is no. So it means that in this kernel memory model, this thing cannot happen. So this gives you some guarantee. If you have a synchronization like pattern, you can make sure that whether it's correct or not. Make sense? Right, you can try it. Go and try it. It's the MP. It's the MP. Yeah, you can see my. Yeah. MP. Start with MP. MP. Yeah. MP. It's in the directory of litmus test. Yes. But the fullback is SMP underscore MB. No, you right now you still yeah your program is right, but I'm saying that the result saying you are currently still succeed. Can you show me the results? What's running? So there are 3 results right here, and the first 2 is now the thing expect, but it's right because you may have the case where this read doesn't read this right. So this can be 0. So it means that so this like the reason this is being a logical expression means that you care about a certain case, combination of the case, not all the case. So if this one doesn't read, so basically the above case means that if the read doesn't read this right, it can the second read can be either value because there is no synchronization there, so it can't happen. Yeah, if you move that, you should you can still see that yeah, you also need to change that. You want to see yeah, so here you can see you have 4 outcomes and all the combination, and then it's the positive and negative means that whether it hit the expression you care about. So there are two part of information. One is the first part is basically what of the outcome can be, and the okay or to the positive part is that whether it's matched to the thing you care about. Yeah, right. Yeah, yes, right. So one condition, one time it's matched. Yes. You can still match. So I think try to do yes, try to do R0 equals 1 and R1 equals 0. Yes. And you should see that because previously you should not see that, and now you move the barrier to the place where it doesn't really work for your case. So you should see that. It means you can detect a bug because you want to guarantee that if the first read the bug, on the second read have to read 1. But this means that your program is wrong because you cannot guarantee that. So they are all default 0, yeah. Yeah. Yes, yes. Yeah. 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 Yeah, this doesn't really matter to your program because you only so here you care about the most case where if R0 is 1, then what will can you guarantee that R1 is 1? That is the correctness of the program. So mostly like if you get a log, whether you can read that value, that's most important thing. Yes, right, yes. So the case here to check is that whether the bad case can happen. So it's if yeah. Yeah. Right, yeah. Yeah, right. All right. I think I'm just going to unshare my screen. So this is actually correct program. Yeah, this looks correct. Yes. So it's verified by the outcome cannot happen. Yeah. No. When you're running that, it's when you run original one, it's showing like a. I think we're done. Yeah, we're done. Your algorithm. Right. Yes. This is like giving you the confirmation of your algorithm is correct. So. Yeah. So yeah, basically you have to consider about all the synchronization case you have. Like if you have two threads synchronized with each other, like via some you can customize this program to be your own program, but it's going to be like example of your algorithm. It won't be like exactly thing. Yeah. Huh? Yeah. Yeah, but you also have to make sure that where you get the battery. So I will say it's probably more easier as a design tool. When you design your synchronization, you can say, okay, do I need a battery here? They can tell you that answer. But if you have like already a program, you have to figure out what's the synchronization here. That is
So let's say if I'm
yeah. So this can do for one item. So this can do for whatever algorithm you're running, as long as it supports the primitives you are using. So either one item or one variable or multiple variables also works. What I'm trying to say is, yeah, I think we are done here. Thank you. Thank you. I do got the two people know the tool, which is good. Yeah, so
multiple variables.
Yeah.
We kick everyone out, right?
A dependent load.
Yeah.
We kick everyone off.
This tool can help where to put the value.
Yeah.
Yes, right.
If I have single variable,